Hi, Chris.
Hello, Jon.
Hi.
How are you?
I shall say good morning or good afternoon.
Good afternoon to you.
Yeah, for me, good afternoon. For you, good morning. Oh, I also see the T online.
D is online also.
Yeah,
Yes.
also. Yeah. This afternoon, I will be hand over to you, but I still will be on all the meeting room and quite a lot of maybe the online people. I have seen we have the online have the 40 people, no? Yeah. But I suppose we have more, yeah, for the European side. Yeah.
That's very good. Very good.
15, yeah. Increased, yeah.还差多长时间？还差2分钟吗？ We still until 12 o'clock.
Yeah.
Right. Yeah.
Have you many attending the conference in person this year?
Sorry.
Have you many people attending the conference face to face this year?
Yeah, we are not too much, just because Beijing have the pandemic. We have the people in Beijing, and but originally most of the conference have the remote, but only our conference still work because we have quite a lot of scientists, including some people from USFDA, USDA, and also EU coming. So we cannot move, but we limit the physical participant into the less than 200.
Okay.
Then they can keep come out. Total in the room limit 200, less than 200. Yeah.
So I hope next year when the conference moves to Shanghai, it will be back to everybody will be present face to face.
Yes, I hope so. Next year in Shanghai, then we can to be just in physical participant, but yeah. I'm not sure.
I know.
And also, I would like your asset in London to be continued.
Yes, we're planning that. We'll have it absolutely in person next year for sure.
Okay, November 4th, then we can continue to see in the Russia.
Yes, and Russia as well.
Yeah. These 7 days, then I hope every day we can see each other. Before yesterday and today, and then we will be November 4th and continue. Yeah.
Perfect. Yes.
Okay. Okay. I just make a brief introduction for you, then hand over the conference chair to you.
Okay, we'll start the afternoon session. In the morning session, we had intergovernmental cooperative programs, and we just reported what we have achieved. In the afternoon, the European partners will share their results. We have Horizon 2020, and these are programs undertaken by European scientists. I have my friend, Dr. Christopher Elliott. is from Queen's University Belfast. He will be the moderator. Now, I'd like to hand over the floor to Professor Chris Elliott.
Okay.
Thank you very much. So it is good morning from Europe and good afternoon to everybody in China and Asia. It is my pleasure to chair this session at CIFSQ. It is one of my favorite conferences in the world, and I really do hope next year in Shanghai we all come back and are together. But for the moment, this is a very virtual session, and it is giving information about a very large, very important research project called EU-China SAFE. For the past 4 years, we have groups of scientists and researchers working together from China and the European Union, looking at many aspects about food safety and food authenticity. This morning, we had a really good program, and the speakers from China gave huge amounts of information, detail about the topics that they were leading on. Now, this afternoon, it's the turn of Europeans to try to convince everybody that we've been doing a very, very nice job together. So it's my absolute pleasure to introduce our first speaker. Our first speaker is Dr. Di Wu. And Di is actually working in my university at the moment, Queen's University Belfast, on a very, very prestigious Newton International Fellowship. And Di has been one of the main organizers of EU-China SAFE. And we're going to open the session. Di's going to give a presentation about work that he is leading currently on tea. So what we will now is the floor over to you now, Di, and I very much look forward to your presentation.
Thank you very much, Chris. So let's share the screen. So Is it showing? Yeah, I see it. So good afternoon, everyone. This is Di from Queen's University. And so today we would like to talk about the story that we would like to carry on our story because the overall approach of this program is to establish a consistent and sustainable relationship between the EU and Chinese regulations and this research institute, and be a part of the impact as being exported to the Queen's University. And we wish that we could just extend this very good relationship with several other international collaboration frameworks. So the T will be a good start as a following project of the collaboration. And speaking about the T has been one of very important parts of human food culture. And especially in Chinese culture, it has a history over for 2,000 years. And the tea trading, now the tea has become like the tea has become like the most popular drink worldwide. And the trading of the tea could be tracing back to 1,000 years ago, ever since the Silk Road was established from the ancient capital Chang'an of Chinese Empire to the capital Constantinople to East Rome. And it's very interesting finding that you can see from different cultures that the name of the tea or cha was adopted by how it was being introduced to the culture by the land trading way. So these countries will be calling the tea after cha, and for the tea navigation way, they will be called after. And nowadays, the tea has been, the global tea market has grown into a market worth of 200 billion US dollars, and China, India, Sri Lanka, and Kenya still remain yet the 4 leading tea producing countries, which produces more than 60% of overall tea production worldwide. But there was a growing trends with tea growing activities in those African countries. And another fact is that most of these tea growing countries or tea producing countries are among the medium to low income populations of the society. And in the contrary, we could see that the tea consumption, and to my surprise, that China wasn't actually the country that consumed the most tea by person in the world. It seems that Turkish and British people and Irish people are among the people that most addictive to the tea. But we can see the other fact is that even though these African countries and also these developing countries which produces most of the tea, but they are not these people who could benefit from that beverage. And if we look at the European markets, yes, UK and Ireland still yet remain as the leading country with the tea consumption, and also then followed by like these countries like Germany and Poland and Russia. But I think there's a major difference about the structure of the tea supply chain. Because when we're looking at the global tea market, yes, China still remained as the largest tea consumption market, like global wise. But most of the tea that consumed in China, they were just produced like domestically. Like overall, not more than 99% of the tea are being produced in China. And a similar case was in India, but they also exported a lot of their products to the European markets. And for the African countries, only a very limited small part was being consumed like domestically. And most of the rest part was being exported to the European countries. And we can see that the tea has kept a very massive, not massive, but just like a significant growth among the past decade. We see average growth rate over 10% each year. And it was going to be predicted to be reaching like $300 billion by the year 2025. And the supply chain has also showed a difference between these countries, likely these countries, likely China and India, because most of this tea were just like consumed domestically. So the supply chain will be much more shorter and easier compared to those with the European markets. Usually, likelihood in Chinese tea plantations, the primary unit for the tea production was like small farmers or these landowners that they own a little bit piece of their own land that produces this tea, and then these tea companies will just come to collect these fresh tea leaves each year during the spring, and then just produce them into like products and then packing them and then sold them directly to the markets. So there will be less retailers, and in some more specific cases like these higher GI values, because the most efficient way to assure its authenticity, most of these consumers, they would like to directly go to these core regions of these GI products, and then which means geographic indication products. We'll go to this GI core region to purchase these products directly from these tea houses or tea plantations themselves. But for the European cases, because most of the tea were just being imported from the from these Asian or African countries, so there has been like more steps with the retailers and exporters and blenders or packers being involved in the supply chain. So it's more likely to be increasing the vulnerability and the chances of adulteration being conducted during the supply chain. And when we speak about the different types of tea, it's basically about the degrees of fermentation and oxidation process that's being issued during the process to produce the tea. So if the tea was not being fermented at all, then it's green tea. And when it's the deeper that the fermentation process went on, the deeper the color will be. And that is actually, just producing a more challenging question for the chemists, because these chemical fingerprints have been changed dynamically during the oxidation of the process. And basically, the tea is relatively a similar plant, or we could say it's basically the same plant variety across all these the same species for all these varieties. But during the past 2,000 years, with different varieties of the Chinese teas, they have been just characterized in different cultures and different environments. So they might have generated like slightly difference between the genetic background, but these teas that being produced like within like the recent 1 or 2 centuries, like this tea that's being produced in India and Kenya, they're more likely to share a more similar background, the genetic background, because the most ordinary way of the tea producing is or amplifying the tea production is through cutting. So it's basically people cutting a stick or a branch of the tea plant and then stick it to the ground, and they will be coming up as a new plant. So it's more likely these variants and differences of the tea was being contributed, these flavors difference and quality difference is more contributed due to the epigenetical factors of the induced by the environment, and also like a stressed reaction of the plant, kind of environment, soil, elevation, and also like reinforce different environmental stress. So these represented like 3 typical scenarios that the tea were produced. So likely for the first picture shows like the Hangzhou Longjing village, which the tea was produced like on the mountain areas. So basically the tea is actually a originally a semi-tropical or tropical plant. So it does not survive a harsh winter. And for most of these parts of this tea that's been produced in China was like this scenario. And but in the country like these Kenya and also Africa, many of these African plantations, we can see that it's a relatively plain-like ground, which these farmlands originally was being used to generate this tea. And also you can see on the right was like one of the most priceless tea that's being produced in China, which is the rock tea, which these tea plants originally lives on these cliffs in the mountain area and now being amplified in these fields next to them. So this is why that the production ability of this tea product is so limited, that's contributing to its price. And because of these 4 leading tea producing countries, they always have their own unique situations with the tea production activity, and also a different contribution and structure to the price factors. So we would like to discuss them like separately. So like first of all, of course, it's the Chinese case, and it's most probably like the most complicated case among all, because in China, that the tea is widely being spread all the way to the south of the Huai River, which is almost equal to the frozen line of China. So to the south of the frozen line, there is tea being produced. And there's, I think till now that there has been like at least more than 200 ordinary tea products available on the market. So likely for some of these provinces, each province might be carried with more than 30 or 40 different varieties. And so for the Chinese government, we have issued the geographic indication protection system for these historically famous or prestigious tea products. And in general, they could be divided like in 4 major tea producing areas. And most of the part of the tea producing regions, except for the southern boundary part, these tea products are amongst like green tea varieties. And there's like to the southern border of the country, this tea produced were more likely to be like oolong and the black tea. And so here we have selected like the 10 most popular tea in China, which is actually a rank that's been performed by the Hong Kong people in 2002. There are like different versions of that, but you can see that among these top 10 popular tea in China, the 7 of them are green tea, including some of these teas that could be tracing back to Song Dynasty, which is almost 800 years ago. And also like some of these very famous like Ui tea varieties and Keeman black tea. These teas are more likely to be well known for the European consumers. But when we talk about the GI products, the problem, the authenticity will be a very headache problem for the government regulations and for the consumers, because normally consumers does not have any idea if the tea is authentic or not. Likely here we propose the case of Longjing tea study here. So we can see that originally or traditionally, the core producing region is around remarks the tiny little dark green dot in the center, so which is about 1 of the 50 of the area of the province. So it's also been categorized into 5 central regions of the tea producing, which is the Shilong, Hu, Meiyun, these 5 key central regions for producing of this authentic tea. But the maximum production ability of the tea is only about 10% of the tea produced overall of this whole region, because nowadays it's most probably like most part of the northern part of the Zhejiang province, they are considered as the producing area for that GI product. So we can see that with the Qiantang and the Yuezhou area, they produce the rest of the 90% of the tea. But there's a simple fact that this tea, especially this tea produced in the Longjing village and these royal tribute, these 18 plants that used to be the royal tribute to the royal family exclusively, their price could be like 1,000-fold compared to the ordinary products that being produced in the rest part outside the central core area to produce Longjing tea. So which means that the profit room for the economic motivated adulteration is huge. And there's also another change of EU and Chinese regulations, because just last year, we have signed a landmark agreement to protect mutual geographic indications, labels, and products. And we can see that with these 2 lists, overall, like 59 products out of 275, they are tea products. So this is actually an approach or a moves of the Chinese government trying to introduce like the higher end of tea products to the European markets. And also for the Indian products, it's also about the GI products, which is leading the higher end of the tea market. So it's always but compared to the Chinese tea, the Indian tea is more well known to the European markets, especially for British people, because it's most probably like the British people themselves have made or introduced the tea to Indian. And we could see that historically the Darjeeling tea and Assam tea, they're among to be believed to be the best quality for the black tea varieties of the European consumers. And also there's also different like Negro and also Kangaroo tea has been like being introduced to the market as well. But the price difference between the GI and non-GI products is also huge. And a similar case was being introduced in Sri Lanka too. But the tea production in Sri Lanka, they are more likely to be characterized about over the elevation of the tea producing areas. So like the central tea producing areas like Nuwara, they were considered as the highland or high ground area. And because we can see that on the island, the central part has a higher altitude and the surrounding part is about the sea level. So it is believed that the higher the land that's being produced with a tea, which is about 1,000 meters, has a better quality compared to the rest. And also the British people have helped the Indian people to develop a unique tea classification system. Just doesn't, because I think in the Chinese tea grading system, we don't have a similar classification system. For the Chinese classification system, we only classify the tea grades by its physical appearance, and perhaps like if the tea leaves remain like an impact or integrity, integrity. But for the Indian tea, they're actually taking like different parts of the leaves from the plant to make the tea. So the fresher or the newborn leaves, if they're taken, they're believed to be like the higher price and higher quality. And the larger leaves were used in the tea, then it's going to be believed to be like lower quality. And also, it's always one thing that's been shared among the Chinese tea and the Indian tea product is we always send the lowest quality, which we also always consider that these powdered or trunk tea as the lower quality tea varieties, and the loose leaves are always better. But I think for the European consumers, they didn't really have that kind of concept, because when they were being packed into these tea bags, they didn't really care or know what are being contained in these bags. And when we're speaking about the African countries, we can see here as UK's tea import as a very good example. There has been like a constantly growing tendency or in recent years about replacing the traditional Sri Lankan tea with the Kenya tea. We can see now that the tea and Malawi tea is not dominating the UK tea market. But I think a lot of these consumers in the UK market, they have no idea where that tea are actually coming from, because usually I think most of these suppliers, they won't just print about the geographic origin of this tea on their package, except they want to highlight themselves to be something like Assam or Darjeeling tea, or they will be more likely to keep it hidden or as a commercial secret. And we can see here that also a more detailed figure with the Kenya case. And we can see a constantly growing rate with the tea producing in Kenya. But nowadays that the Kenya tea industry is generating about 26% of the total export earnings and about 4% of the whole GDP of the country, and which also supported about 3 million people are earning their livelihood on this sector. But there's also another very important, it also had become a very very important issue about the worker welfare and livelihood for the poor, for these people, because most of these people who's been conducting the tea producing activity, they're amongst the poorest of the poor. So which their average annual salary was even lower than $1,000 US. And also there's issues in these African countries about like sustainability with the environment, because there's the climate change has been changed, the diagram and also the distribution of the tea producing areas in these African countries. And also there's also issues about deforesting to generate more lands for tea production, and also like the exchanging of the traditional farmlands into tea growth. So all these factors together, they become like to be contributing as a general price factors for tea. So it's always about the geographic indications for all these countries. These authentic GI products always carry with higher price and values. And also there's also for the Chinese cases, there's also like two very important factors, like the timing for the green tea. So there's two very crucial timing points in the spring, so which is the Qingming festival and the Gu Yu. So these are when the tea ready to be harvested, and it's always the fresher the better. So during this timing that the tea price could be so like at least 5 to 10 times compared to ordinary to the other times. And also there's a vintage factor for some of these black tea varieties like the pu'er. So the more aged the tea is, then the tea will be likelihood to be sold in a higher price. And for the cases of Sri Lanka and India, it's also about the GI and the elevations and also the classification, the classes of the tea that we mentioned earlier. But the question will be, what is the tea quality for the European consumers? Because I think nowadays, most of the European consumers, they have no idea about their quality of the tea because their tea drinking culture is quite different from the Asian people. It's likely for the British people, most people drink black tea and they add extra additives, not additive, but extra ingredients into their tea like milk and sugar. But when Chinese people, it's always about the tea itself. And also for the consumers, they have no idea about what the authentic tea should be tasting like, and they have no idea tea are actually source are coming from. So these have been introduced a huge risk about the existence of the adulteration. So when we are trying to identify the fraud in tea, the first problem we will always, the first question we will always propose is your tea really tea? Because we actually receive some information from our industry partners saying that there are companies trying to add husks and also like flavors, caffeine and dyes into the tea bags, try to make a tea bag out of rice husks tasting like tea. And also according to the Indian tea board, there has been like dyes, graphite, and also spent tea are a lot more most likely to be the most commonly seen adulterants in their tea industry. And actually, when some of our friends are sharing some of these testing reports from the European markets and European retailers, like a quality test reports from these tea extracts to or generate those tea drinks in European markets, it's surprisingly to me that none of the catching was ever measured in there. So it's always about primal nutrient parameters and also likelihood, like how much calories, sugar, protein, fat, and sometimes polyphenols, that's the most. But they never test about catching inside their products. But luckily for us in China, we have the GB system to control the quality of the tea drinks. But it's still surprising to find that these tea drinks have only obtained like a very limited of tea inside their drinks. So even the highest tea drinks in China, they actually contain like only equalized to 1 gram tea in their bottle. But when it comes to average tea bags, it's minimum like 2 grams per each bag. And for likelihood for the Chinese traditional tea drinking ways, like we usually use 5 to 20 grams for like 500 milliliter water. But so it's always better to drink directly from your teapot, relatively compared to those what to be called tea drinks, because they are not really tea drinks. They're only like a sugar drink with a minimum amount of tea. But that's the Chinese case. But for the European cases or for the Southeast Asian cases, we could only wish them luck because we cannot even confirm that this product being sold to them as tea extract is really tea. So it's time to get on board. In order to conquer or to win this battle against these potential fraudulence, it always takes about different collaborators from different realms, including academic and also governmental and the industry to work together. So we are actually trying our best to reach out to all these available sources and collaborators we could reach both. So nowadays, so till now, we have been very thankfully to the Agilent Thought Leader Program and Rural Society. So we are actually able to achieve the collaboration, to establish the collaboration network across the tea industry. So in China, we have found the Sino-Light collaboration, which the Serum Refi, and also like the Zhongshan University and Shanxi University of Science and Technology and CIFSQ to be our Chinese collaborators, trying to help us to develop this methodology and also to collect the authentic samples from the tea in China. And also we're working with our local suppliers and also retailers in Northern Ireland, likely for the Thompsons and also the Sticky Tea. And also we're reaching to the media partners like the New Food and the PMD. And on the right part is actually these partners we're trying to reach to and still under negotiation. But we are still at the very beginning stage, trying to obtain more samples from different multiple sources. And we're really looking forward for more partners to join us worldwide. And so far we have collected like overall about 400 samples global-wise. So some of them are from China and Kenya, Ethiopia, and these African tea producing countries and India. And we have tried to issue these to test these tea samples with the two-tier analytical platform of IGFS at Queen's University. So in general, this two-tier system will be consisted with two types of technology. So one, tier one, it will be rapid and screening approach technologies, including the near infrared and also FTR and Raman, which are most likely to be spectroscopy based, and also the ambient mass spec. And on the other end will be like for more of the conformational purposes, more likely to be adopted with the regulation levels and going after with more advanced or high dimensional chemical fingerprints. It's really the high resolution mass spectrometry and also the ICP mass. And here's an example of our works we have achieved so far. So these are these tea authentic models that we have established so far by using the FTIR instrument. So we can see that we see basic primal chemometric analysis. These samples from different origins, they give very good separation and very good authentic models. So when we're having like an unidentified sample, we could just try to insert it into these models to see where does it fitting and to see where the geographic origin the sample is actually really coming from. And another attempt of our recent move is trying to implement the AI and machine learning into our analysis, because traditionally we're using like statistics softwares like Simica or a MATLAB. Sometimes we call it like linearized softwares trying to perform these chemometric analysis, but we often engage with these bottlenecks of the sensitivity and the specificity performance of these instruments. But with the AI and machine learning, when we're trying to provide additional training data towards these models, they can be trained and increase its performance by like at least 10 to 50%, or sometimes 2 to 5-fold of their performance in sensitivity and specificity. So we have been adopted the similar approach with the spices that being allowed to lower the limit of detection of the adulterants from minimum 15% to 5%. And a similar approach is something that we are looking forward to develop in the tea authenticity modeling things too as well. And also there's these approaches that we have our recent plans for the next stage. So we'll be continuing trying to obtain more samples from different sources, especially focusing on the Southeast Asian countries and also black tea varieties from China. And we're also seeking for like new opportunity with all these potential collaborators, and also trying to identify like fraud cases in the tea industry. And we'll also try to issue more of these more accurate analytical method towards this data too as well. And so here we will once again try to give our best thanks to the Agilent Thought Leader Program and the Royal Society and also Natural Science Foundation of China to support our research, and also our traditional collaborators and friends with these technical supports. And we would also like to welcome anyone who's been interested in our research and would like to join our team as a part of a team or as a collaborator in all means. And thank you for your attention.
Thank you very much, Dee. That was an excellent presentation. I think you've outlined the complexities of tea. The potential for fraud is enormous. And I think to say that we really would welcome other collaborators to join our project in terms of supplying tea samples, supplying knowledge, transferring the methods that Dee and his team are building at Queen's University into your research centers or routine testing laboratories. So a big opportunity for many more people to become involved in this. So Dee, thank you very much indeed for an excellent presentation starting our session today. What I would like to do now is introduce the second speaker of our session, and that is Ivo Muller. And Ivo works for Danone. And Ivo is going to give us a presentation keeping on the theme of authenticity and fraud. And Ivo is going to give us a presentation about anticipating fraud. So I'm really looking forward to this. We're very involved in predictive analytics, Ivo, so very keen to hear what you have to say. So we will hand over to you now. Thank you.
Thank you, and good morning, good afternoon. I hope that you can hear me, and in the meantime, I will try share my screen, closing out a couple of other screens. Sorry for that. Here we are, I believe.
That's perfect. If you just put on display, perfect. Ivo, thank you.
Thank you very much also for your patience during this technical challenge. Thank you for introducing me, Chris. My name is indeed Ivo Muller. I'm going to talk to you with pleasure about, from a company, Danone perspective, what food fraud means for us, what food fraud vulnerability means for us, and the way how we prevent our consumers and our business to this by means of clear processes and governance. Whereas we are also focusing on anticipation and predictive modeling. I am not the expert on that. We have some programs running to explore the opportunities there with external partners. It will not be the core of my presentation, but happy to have further thought exchanges later on that. Very quick introduction from about myself and then about the company that I work for. My name is Ivo Muller. I'm a veterinarian by educational background, graduated at Utrecht University in 2007, and as well have a degree in the Utrecht School of Governance and Organizational Science. My first job after university has been in the dairy food safety authorities in the Netherlands, which enabled me to oversee the total production chain from farm until the high-end dairy industry and specialized nutrition industry, including also various encounters with authorities from various countries, from China, from Brazil, from Russia, and the like. Also to explain how the official supervision methodology from the Netherlands as a big dairy exporting country had been put in place, and what is the meaning behind the export certificates. So also in that previous role, it has always been that authenticity of products and the true quality of the real products has been at the core of the attention and the core also of my role. As per 2012, I switched employer. I joined Danone in the early life nutrition division back then. I've had various roles within the quality and food safety organization, first focusing a lot on new product innovations, bringing them safely to the market. And nowadays I am here in the role of emerging risks and food standards senior manager for specialized nutrition. I will come back what specialized nutrition means in more detail, but my role is about establishing with my team the current and future food safety standards for infant, young children and medical nutrition. I'm also responsible for the strategy and operational performance on food fraud prevention. I'm not doing that myself only, but I have a team to support me, and together we established this. So far about myself. Then about the company. So I think most of you know the company. It's a company at global presence with more than 100,000 employees in over 55 countries. Our products are being sold in more than 120 countries, and 67%, so 2/3 of the sales are outside Europe. If you look at the product portfolio and the large chunks of the business, you see that there are basically two parts. The first part is aimed at the general population, and the products belong to the essential dairy as well as increasingly the plant-based category. The second bit under general population products are around waters and beverages. So the Mizone is what you probably know in China, but maybe based on the pictures you see here, you are familiar with a couple of more of these brands. Then the specialized nutrition, that is the part that I mostly work at, is for infants, young children below 36 months of age, as well as medical nutrition. And you can get a glimpse of the wide variety of products here. So where we're talking about infants, we're talking about products that are replacing breast milk. So infant milk formula, follow-on formula, and young child formula, for instance, for the different age groups. What is particular in those products is that most of them are sole source of nutrition products. So it's very important if this is the only nutrition that a child gets or an infant gets in the first months of age, it's of extreme high importance, as you know, that its composition is truly as it should be. So it's not only about microbiological control, not only about physical risks or contaminants, but as well as nutritional parameters that need to be well in line with the requirements of the infants at that stage of age. That's an important part of the specialized nutrition portfolio. There are various products which are aimed at people who are in hospital to strengthen or have specific diseases or metabolic disorders. So that's also a large part of the specialized nutrition portfolio, including medical devices to make sure that the products can also be consumed. Some of our patients cannot eat and swallow themselves, so we need to have certain devices like tubes, etc., to make sure that the patients in the hospitals or outside of the hospitals can benefit from the specific nutritional solutions. And next to that, there are also more complementary baby foods like jars, like vegetables, fruits, particular cereal products that are not sole source of nutrition, but are still in a quite regulated framework in the various geographies. So not only in Europe, there are strict regulations for baby food, but also in other countries, including China. That's the reason why we've separated also within our food safety governance model, the general population products from the more regulated specialized nutrition products. So far, a short introduction about our company and the type of products that we produce and that we offer for consumers and patients worldwide. And we do that, and I think that's an important element to mention here, based on the manufacturing network of 27 factories for specialized nutrition worldwide. More than that, also sales units worldwide. We have also external manufacturers, so-called co-manufacturers, that help us producing our brands. And in order to produce our finished products, we have partnerships with more than 1,000 material suppliers for ingredients and packaging materials and the like. And that's exactly why it is so important to have clear internal and external standards and processes to safeguard the quality and the food safety of our products. And at the same time, it is important to keep in mind, if we want to develop, which we have, a strategy how to make sure that also food fraud that may come from the upstream is avoided and prevented together with our partners as much as possible. So that brings me to the quality and food safety mission of the company, which is to excel in quality everywhere, every day, to deliver our promise to consumers and customers, as you can see here. And in order to do so, we want to be preferred. We also need to be efficient. It's very important to be trusted. And if that is all in place, we can also be proud. I would like to highlight two aspects out of this food safety mission, which are key elements in my view when we're talking about trust. So it's indeed to be trusted and also to deliver upon our promise. So basically, it puts us in the responsibility and the willingness to really put consumer trust at the forefront. That is really what we need as a company to protect. In order to do so, we need to cover both unintentional adulterations, the traditional food quality and food safety risks, with the unintentional presence of factors that are of non-quality or that could have a health impact. Those are the traditional factors that are covered by our food safety and quality management system. However, increasingly, we have expanded our attention over the past couple of years also to the unintentional adulteration. And as you know, these are the areas of food fraud and food defense, where the fraud part is driven by the motivation of economical gain, and the food defense part is more ideologically driven with the motivation of harm. So how have we set up our strategy and our systems, our infrastructure within our company to fight against food fraud? So the rest of the presentation will be about food fraud. There are two pillars. One is focused on investigation. that is really in case we have suspicions or proactive investigation, to make sure that we further investigate if a situation that we encounter is actually a fraud, potential fraud case, but then also to work together proactively with international or national organizations and agencies like Europol to dismantle the network of organized crimes and feed our system also learnings of those investigations to make sure that we increase the way how we are protected. So this is an really dealing also with criminal groups, and you can imagine that this is not a task that is put to the, let's say, traditional quality and food safety functions of the business. This is clearly led by the Danone security department with specific skills and specific expertise and mandates. Having said that, there is a close collaboration and partnership between Danone security and the various quality and food safety functions within the business. The more proactive part of our model is focusing on prevention, and that is led by the food safety department. I play a coordination role in that, and for the execution also together with the quality organization. So what is expected from the preventive pillar? That is to identify, also to assess and to mitigate major food fraud vulnerabilities. So those, as you know, vulnerabilities are events that have not yet occurred, but there are weaknesses in the signal in the system, and our system is focused on detecting those weaknesses to map them against others, to prioritize the greatest weaknesses, and to make sure that those weaknesses are then addressed, especially if they are above our risk tolerance appetite. In order to address those vulnerabilities, it's important that we don't work in individual functions, so only within the quality and food safety function or only within the security department. It can only be a success, has been shown over the past couple of years, if you have a cross-functional involvement, including marketeers, R&D, people who really know the markets or the supply chain, our buyers. So it's all about a close collaboration and a partnership. And it's this preventive part that I would like to focus on in the next couple of minutes that I still have. So for the, what are some key elements of the governance for food fraud prevention? It's first of all to have a clear aim. So what are we aiming for? We are aiming for two elements. First of all, compliance. Compliance to our basic promises, to our GFSI certificates and the like. So that means that each of our factories need to be able to demonstrate that there is an annual food fraud vulnerability assessment, that it takes into account all the products that are incoming and outgoing, that it is part of the food safety management system and the like. This is the compliance part, which is important. But some steps further, that's also where we aim for. That is to really have that these measures that we identified and prioritize are having a protective effect. And we do that also based on a clear prioritization. That means that of the major vulnerabilities that have been addressed throughout the chain, we are mapping them against each other, making them more concrete. What are, for the business as well as for the potential health impact of these fraud vulnerability, the first ones and then the second ones to be addressed. This is the thinking part and the analytical part, but then it's the executional part. So for that, we are mobilizing preventive action, first of all through procedures, but more and more also through training. So we need to make sure that employees, regardless of their function, are aware of what food fraud is and what they can do and what is expected from them in their function in order to help us to protect our consumers. And next to that, it's what we have in place is also a progress monitoring on those various projects that are ongoing to make sure that we really drive progress there. We have a whole value chain approach, so that means that we are looking at our incoming goods, so all the material supplier combinations. We're also looking at our inside, so what happens in our own factories and in our three-party manufacturing sites, as well as in the supply chain, the warehouses, the logistics, up to the moment that it ends at the consumer or the patients. In the various parts of the chain, you can imagine that there are various types of fraud that that should be addressed. For the sake of time, I will be very quick on this one, but just to make sure that we're talking about the same thing. Food fraud vulnerability, meaning a weakness or flaw, creating opportunities for undesirable events, meaning company exposure to fraudulent activities. And the key factors to determine the fraud vulnerability are, as also referred to in the previous presentation, the opportunity. How easy is it to conduct a fraud? Can you recognize as a consumer what is authentic tea here or not? The motivation, that has all to do with money. In the example of the previous speaker, the price difference between real tea of high quality and tea of lower quality, and the price difference of a factor of 1,000 is a key motivation. I don't think that needs any further explanation. That is the risk part of the equation, but also together with the control measures that are put in place throughout the chain, in our factories, with our suppliers, etc., gives the actual fraud vulnerability. I mentioned already that we apply a full value chain approach and multidisciplinary assessments. So where do we do this, conduct these food fraud vulnerability assessments? It's first of all an integrated process in our quality and food safety management system, and these activities are conducted both at local level as well as more central, global in the company. So already mentioned, all the business units on local level are expected to conduct at least at annual basis a food fraud vulnerability assessment. If there are situations that ask for more often updates, this is also mandatory. And for some of the food fraud vulnerabilities identified, the local sites would not be best positioned to put the mitigation in place, but in those particular instances, those vulnerabilities are supposed to be escalated to the global teams, making sure that either in the procurement part or in other parts of the business, we are putting in place the right control measures. At a global level, there is an annual creation or a revision of the food fraud risk maps that help with prioritizing the highest risks, linking it to enterprise risk management, making sure that there is resource allocation, people and money to those projects. And that results then into the development of mitigation strategies and solutions for the prioritized risks. And of course, this comes at the service of the local teams, not only with the solutions themselves, but also with specific expertise, tools and training. So at Danone, we have food fraud prevention integrated into our existing quality and food safety processes along the value chain. So there is not a separated food fraud prevention management. Food fraud is an integral part of quality and food safety management in the sourcing and the design part of the circle, also in the manufacturing part and the warehousing, logistic and sales. I'm looking at the time, and I think I need to wrap up. So the key takeouts on effective prevention from my perspective is that the scope of food fraud vulnerabilities, it's very important that it takes into account not only a particular part of the value chain, but the whole chain. So inside the company, outside the company, before it enters our factories and after it leaves our factory gates, until the moment that it is in the actual marketplace via all the various channels. So via the traditional channels, but also via e-commerce and the like. Then very important to have a multidisciplinary approach, both at local and at global level. This is not a task that you can simply put just and only on the plate of the quality teams. What helps is to have a very clear process on food fraud prevention with a clear aim and a clear governance, including the link to enterprise risk management and a clear tracking of the projects that are prioritized. As I said already, embedded food fraud prevention in the company processes and food safety management system. And a key enabler for mobilizing preventive action is awareness and training. So next to developing new solutions, sometimes together with external partners to help us protect the authenticity of our products. Next to that, we also focus on education, on trainings, including educational games for our employees to make sure that we are all aware what our role is in the battle against food fraud. I hope that this gave you a nice impression. It was quick about some highlights, the way how we as a global company are not only investigating potential cases, but also putting in place preventive actions to avoid that our consumers or patients, as well as our business, are being hurt. Thank you very much for your attention.
Many thanks, Ivo. That was a really good presentation. And thank you for stressing the importance of prevention as well as investigation. That was very clear. And knowing that it's all of the anti-food fraud measures are embedded within the culture of the company is very, very important information as well. So thank you for that. I was also interested that the Danone Security Department leads on the investigations. And I think that gives everybody a clue about how complex some of the investigations can be. So many, many thanks indeed for that. We'll hand over to our third speaker for the first part of this session. It's Professor Jana Haslova from Prague. And Jana, another important partner in the EU-China Safe project, and has very much led the work on pesticide analysis. And pesticide analysis can be very tricky, very complicated. And what Jana is going to do now is give us some information about the current challenges in terms of pesticide residue analysis. So Jana, lovely to see you, and over to you now. Thank you.
Thank you very much, Chris. I hope you hear me well. Is it okay? Hello?
So we can see your presentation. It's a little bit difficult. It's a little bit difficult to hear you, Jana. You're breaking up a little bit.
Hear me well?
We're still struggling to hear you. Have you any headphones you can put in?
Well, because of yesterday university was closed, but I hope you will hear me. I will speak slowly. Is it okay?
No, we're really struggling to hear you. It's breaking up very much. Have you got a set of earphones or headphones that you can put on?
I university, but it was closed. I could not go there. How is it now?
No,
Is it okay now?
it's still very difficult to hear you properly, Jana.
How should I do that?
So have you any earphones or headphones that you can attach to your computer? No.
So
Okay.
slowly through my slides, right?
Okay. So maybe could you try switching off your camera in case the signal is the problem?
Do that. My camera. Just a minute.
So on the bottom left-hand side, it says stop.
Yeah, I know, but
Stop video.
Let me see. I have switched the camera, right? My camera is off.
So unfortunately, we still can't hear you very well, Jana. Maybe can I ask you to log off and log back on again, and perhaps you'll get a better connection.
Sure.
So just while we're waiting for Jana, Jana has been doing a huge amount of work in the EU-China Safe project in terms of pesticide analysis, and particularly looking at issues around fraud in organic food, for instance, where pesticide levels should be absent or at least very low. And there has been a wonderful exchange of knowledge, information.
Is it now better?
I'm afraid not, but I think if you can just go ahead with your presentation, we'll be able to see your slides. Okay, Jana?
Mm-hmm. There is my presentation. Just a minute.
That is much better now, Jana. Yes.
So I hope it will work now. Sorry, I cannot affect it in any way. And now we'll just upload the slide, and I hope it will be finally good. So, do you hear me well now?
It's a little bit better, but we can't see your slides.
Yeah,
we can't.
no slides.
If you could share your slides, that would be great.
Yeah, sure. Now, slides are there.
Perfect. Just go into display mode.
Okay. So now the slides are here. Thank you very much again for giving me the floor. Talking on pesticide analysis and challenges I see. Right. When you have a look at this slide, there is a lot of hazard notification in European Union depending on the world region, and the most often it is coming from Asia or Europe. And when you have a look on the system behavior, it's rapid alert system for food and feed. We call it RAS. And this system works perfectly because it collaborates governments, private companies, and consumers, and so on. And we are tracing the hazard and announcing on our market. And therefore, at the beginning of my talk, I'm going to show you a few slides related to that. Ethylene oxide is new emerged contaminant, and as you can see here, it's very difficult as it is classified as carcinogenic compound, and it mainly occurs in seeds, spices, number of food additives, milk, creams, breads, and so on. And it was not monitored in the past decade. It is matter actually of recent 1.5 years. On the bottom of slide, you can see a definition. Ethylene oxide is defined as a sum of ethylene oxide and 2-chloroethanol, and it is altogether expressed as ethylene oxide. And what I'm going to show you here, this is one of the sites of RASF system, Rapid Alert System, and you can notice that since August last year up to now, we had 690 notifications in different commodities and coming from different countries. It was really a difficult situation. And just the next 2 slides will show you how we did cope it with it. And what we did, we implemented 2 methods. The upper one is working on hydrolysis of ethylene oxide to yield 2-chloroethanol using acidic hydrolysis in the presence of fluorines. After cleaning, we have the extract ready to analyze by gas chromatography. And the other method is simply for screening, rapid screening. We just extract it by aqueous acetonitrile, and after simple cleanup, we have extract ready for analysis. And as you can see, the method that has been implemented is working well with good performance characteristics, with good recovery, repeatability, and low limits of quantification to be able to control residues. And also accuracy was checked through proficiency testing organized by European reference laboratories. So this is just a note at the beginning that there are time to time emerging problems, and we are always ready in our pesticide laboratory to solve it. And as long as you are interested in more reading, you can go to LCGC journal, and in very new issue you can read our paper on procedure we've been using and have implemented recently. References. And now I'm going to talk already towards the EU-China SAFE project, and I will start this very short overview of state-of-the-art of multi-residue methods on which we focus within our work package. You can see that there are different approaches, historically number of them. However, on the top of cleaning procedures, there is Catcher's procedure, no doubt. The other procedures are only occasionally used for specific purposes because Catcher's has the best cleaning effect. Regarding detection selectivity, again, we have liquid and gas chromatography, of course. However, I'm going to talk about the recently best method that is represented by high-resolution mass spectrometry, as this method has the best detection selectivity and offers many other benefits compared to other procedures listed here. The methods for multiple residues, because currently we have more than 1,000 active ingredients registered, means that we have to find suitable procedure which enables simultaneous analysis. However, we cannot accommodate all residues in single method. We have to use combination of 2 procedures, LC most of laboratories uses MSMS represented by quadrupole, and this is a nice example when using MSMS triplet. One of the ions didn't comply with requirements because its intensity was not correct. Then, when using high-resolution mass spectrometry, we could see the extracted respective ion using atomic mass, and when obtaining high-resolution mass spectrum, what we could see, there was interference which has very close nominal mass, and it was only 0.07 daltons, and therefore it was risk of overestimation. Using high-resolution mass spectrometry, this risk of overestimation could be avoided. The other example shows another case, because sometimes we also have to check it using two approaches. Here is correct classification of Boscarit. However, when we use extracted ion by high-resolution mass spectrometry, and when we obtain a high-resolution mass spectrum, we can see that there is a massive interference, and again, it could distort the quantification, as this interference, when using high-resolution mass spectrometry, is very intensive, 25 times more intensive than our target analyte. However, using high-resolution mass spectrum, we are able to control it. So the conclusion for this case, when using high-resolution mass spec, we cannot use all the some ones cannot be used for quantification. So as you can see, it needs some expertise to work correctly and have sound data. The multi-residue multi-matrix method was subject of our task within EU China Safe project, and this method, which was developed at our university, was transferred to Chinese partner. Here is the task. As you can see, the task was, or the purpose was to standardize these measurements, to focus on problematic matrices and residues, and to also at the end to verify whether the transfer was efficient, to verify it by proficiency testing, small ring test which we organized. Each Chinese partner obtained the standard operation procedure, SOP, describing in detail application of this method. You should also notice that this method, in addition to pesticide residues, which were the target in this case, also enables the determination of mycotoxins. So, in other words, in a single run, you can nicely determine carbendazine, aflatoxin, ochratoxin, and number of other pesticides as far as they occur in your sample. So this is high-resolution mass spectrometry-based method, which was developed within this project. Now, the method was transferred to our partners, and also we organize inter-laboratory comparison study, and the aim of this study was to check comparability of the pesticide data, and also to verify whether, even in case of difficult matrix, as key is whether this method works well, and whether this standard operation procedure advises our partners correctly how to go through this method. Here, this inter-laboratory study is introducing names of our Chinese partners. I should express my thanks to Professor Wu, who very effectively supported us in contact with top Chinese laboratories focused on pesticide residue analysis. So you can see across the country, laboratories participated, and our laboratory was the seventh who delivered data. And nice to conclude that all the laboratories who were invited and who got the sample were indeed responding and delivered the data. Which sample was analyzed? It was tea, green tea, powder. It is a difficult sample. Somehow I just show you that it contains a lot of potential interferences, mainly caffeine and all different polyphenols. So it is really a matrix we have to pay attention. And the sample we delivered to laboratories was powdered green tea contaminated by a number of pesticides. Here you can see analysis performed on the sample in our laboratory at the University of Chemistry and Technology in Prague. However, regarding the sample, we obtained this sample from our other partner from Fera Science Laboratory in UK, and this test material was prepared in line with all regulation requirements, in line with ISO IE. You can see here at the bottom of slide. How was the outcome? Okay, we obtained good responses, as I have already said, and I also should add that this analysis in our lab, which was also used as reference, was performed by accredited method according to ISO 17025. And here finally are the results. As you can see, most of laboratories delivered correct data. There was only a few exceptions with false negative. However, the number of correct results was very high, and all the laboratories were able to report on pesticides, which you can see in the left column. So from our side, it was quite difficult to manage, and again, the support by Professor Wu was crucial. However, we managed and can report that this task has been fulfilled. Here you can just see the table with results. I will not go into details, but only yellow fields are some problems we experienced, but as you can see, there are very few. And also, I should say that in addition to the results, which were satisfactory, we also could get an overview of analytical approaches used by these scientists. As you can see, some laboratories didn't use high-resolution mass spectrometry simply because they were not able at that time. Nevertheless, they use MS triple quadruple. However, they use the recommended sample preparation approach. So they verified this important phase of sample handling. And the other labs just use Q-Orbiter and other also QTOF, I think it was QTOF they used. So we were very happy to have such detailed information, and everything was compliant with our plans. The other task I want to introduce briefly is authentication of organic crops. It was another task within the project. You can see here we wanted to increase the knowledge on our strategies which can be applied for organic fruits or vegetables. Authentication, as you know, it's a very difficult task to authenticate it. There are different approaches, and one of them is also pesticide residue analysis. However, what can happen if you don't see any residues? And that was our new approach we implemented within this method. And again, high-resolution mass spectrometry was used for this purpose. I introduce here the problem we were solving. Actually, the background of study, we demonstrated this approach on biovines because there is really growing demand for this type of alcoholic beverage, very popular here. And as long as it is declared as biovine, then it should not be treated by processes, in phase 2 conjugation with polar molecules, and at the end they are integrated into cell walls and so on. So different processes and number of different metabolites originates from parent compound. What we did? We prepared database using different sources of information about different pesticides metabolic transformation. So in other words, we prepared database of potential conceivable metabolites of pesticides. Which could be monitored when using high-resolution mass spectrometry. In the yellow label, you can see how screening based on high-resolution mass spectrometry was performed and which parameters, which information was used for detection of these pesticides, their metabolites to be correct. And here is an example. How could we apply, how can we use this situation, this approach? For example, we had the sample which was contaminated by sporoxamine, and the finding of residue was at the level 0.01. How to conclude? Was it illegal use or unintentional use? Under these conditions, we added analysis of potential metabolites, and on the bottom of the slide, you can see that the number of metabolites of parent compound were present. We can conclude that in the history, that was not accidental contamination with very low residues. Nevertheless, it was use of sporoxamine, and metabolic transformation occurred with lower the residues. Nevertheless, these residues for sure exceeded this critical value 0.01. So we concluded the sample is fake, it's fraud, it was not organic grapes. And here just few examples how the method nicely works. You can see all these parent compounds and metabolites which we can detect when using accurate mass or ions we screen, although we don't have standards because hundreds of metabolites may originate and not all of them are available, commercially available standards. Nevertheless, we can detect them and we can clearly demonstrate pesticide use. Here is another example. You can see number of compounds, hydroxylated, glycosylated metabolites were present in addition to benconazole, which is a common fungicide used on grapes. For those who would like to read more, we published within this project nice paper, which got from American Chemical Society award as the article of the month. And there are, you can find their answer whether can occurrence of pesticide metabolites detected in food commodities, whether or not can give evidence on illegal practices in organic farming. So this is what I wanted to say to the project. And the very last slides, I just want to show you that in addition to these technically demanding multi-residue methods, which require very high and instrumentation, we also have possibility to make a screening before instrumental analysis using smart sensors. And Professor Elliott and myself, we also participated in a project which was focused on using smartphone as a reader. I will just show you just 2, 3 slides, and just to conclude that, for example, for organophosphates or carbonates, which are neurotoxic the reaction we have proposed and used for this purpose, for detection purpose, this smartphone as a detector, as a reader. And here is the example what happens. We just use specific substrate, acetylcholine, for enzyme. Enzyme splits, hydrolyzes this substrate. We add some specific reagent which yields dye, yellow dye. And now, as long as inhibitor is present, the dye doesn't develop. So, as you can see at the bottom, if we have no pesticide in the sample, the color develops and it's intensive. However, if there is inhibition, depending on the amount of inhibitor, no color has developed. So this is the principle which can be used, and because of time constraints, I will skip the slides in between. Just want to say you that different pesticides or organophosphates and carbamates have different potency. We have some very strong inhibitors like carbofuran and similar, however, different potency, but we can, our strip gives you an answer on the total potential to inhibit the enzyme. And skipping to the very last slide, I will show you here. I will skip that because time is running, and here. Okay, so what we do, we have some inhibitor, incubation where it is local, we add a substrate, and then using the smartphone, we just record video, and the principle is that we measure color intensity against the blank, and then based on the difference, we have you can see the difference between blank and measured samples, and based on that, we can even estimate, thanks to the software which is uploaded in the smartphone, we can read or estimate the amount of inhibitor occurring in the sample from which it was isolated by catchers. So this is just the future vision. So screening analysis for positive samples. That's the idea, saving time and money. Okay, and the last slide is just simple invitation. You may wish in coming days, join. It is for free. You can just register to refer. A lot of great speakers will be there, and including Professor Wu and Chris, Professor Elliott, recorded talk. So we are looking forward to you, and there is more space to talk about challenges in pesticide residue analysis. Thank you.
Many thanks, Jana. There was a huge amount of information about pesticide analysis, the importance of it, the complexities, and it's not only about regulatory compliance. It can be used as a tool to detect the potential cheating on organic as well, and the advances in smartphone technology is really interesting as well. So thank you very, very much for that presentation. What we're going to do now is we'll take a 15-minute break, okay? Time for those people in Beijing, go get some tea, coffee. For those people in Europe and elsewhere, time to go in your home and get some tea, coffee. We'll meet again in 15 minutes from now, and we will hear the second half of this session. So I'd like to thank our three speakers this morning for giving us a huge amount of very good, very valuable information. And I will see you all 15 minutes from now. Thank you. So welcome back to the second half of our EU-China SAFE sessions. I hope all of you in Beijing have had a chance to have some refreshment and you're back in the meeting room again. And also for all of the participants sitting at home or other places who are online, welcome back also. It was my great pleasure to introduce this part of our session, and that is Gemma Regan. Gemma works at Chagas in the Republic of Ireland, but is also a PhD student at Queen's University Belfast. And this is a very, very nice and very important day for Gemma, because literally 2 minutes before this session started, Gemma had her publication accepted in Analytical Biochemistry. So congratulations, Gemma. So this is your first presentation of an accepted piece of published work. So it's very, very good timing. So Gemma is going to talk to us about the wonderful work she's done on the China SAFE project in terms of nitrofuran residue analysis. So Gemma, with great pleasure, over to you now.
Thank you so much. I'm just going to share my screen now. Is that all visible and okay?
Perfect, Gemma. Thank you.
Brilliant. Thank you. So good morning or good afternoon to everybody, depending on where you are in the world today. As Chris said, I work at Chagas Food Research Centre, and I'm also a PhD student at Queen's, and my EU-China SAFE PhD project looks at developing new methods for the detection of antibiotic residues in food of animal origin using LC-MS. And in particular, my research focuses on a group of antibiotics called nitrofurans. And today I'm going to be presenting on the development and application of a new LC-MS method for analysing 8 bound nitrofuran residues in meat. So firstly, what are nitrofurans? So they're a class of synthetic broad-spectrum antimicrobial drugs, and they were previously licensed for use in veterinary medicine for the prevention and control of disease, and also as feed additives for growth promotion. They are known to be active against both gram-positive and gram-negative bacteria. And they are defined by their 5-nitrofuran ring in their chemical structure, but their exact mode of antibacterial activity is currently unknown, but it is thought they inhibit several different bacterial enzymatic systems. So they are mainly bacteriostatic, but are known to be bactericidal at higher concentrations. So nitrofurans are known as prodrugs, which means they are administered in an inactive form and then are subsequently metabolized into their active form. And in the case of nitrofurans, they're actually administered in their parent form and then become rapidly metabolized to form highly stable protein biometabolites. And these metabolites are known to pose a threat to consumer safety due to the fact that they have undesirable toxicological properties, including carcinogenicity, genotoxicity, and mutagenicity. And because of this, they have to be monitored in food to protect consumer safety. So, as I've mentioned, the parent drugs are rapidly metabolized, so they have very short half-lives in vivo and become undetectable after a few hours. And because of this, they are unsuitable in that form to be monitored. So instead, they are monitored as their protein biometabolites because they are known to persist for very long periods of time and hence are ideal marker residues for nitrofuran analysis. So because of their threat to consumer safety, the nitrofurans became completely banned from use in food producing animals in 1995 in the European Union. They are classified as Class A, Group A substances, meaning that they are completely banned from use and are zero tolerance. And because nitrofurans are considered as non-allowed substances, maximum residue limits or MRLs don't exist, and instead they have reference point for action or an RPA. And in 2019, that RPA was reduced by half from 1 ppb to just 0.5 ppb. And that RPA level is just going to get lower and lower as the years go on due to advancements in technology and more sensitive instrumentation. So since their ban, a project, an EU-funded project called Food Brand was set up with the aim to develop methodologies to monitor nitrofuran misuse in food. And as part of this initiative, a confirmatory LC-MS method was set up, and it detected 4 main nitrofuran drugs. And since this method was developed, the majority of methods since focus on these 4 main drugs, and their structures are shown in this slide. So as I mentioned previously, their defining structural component is that 5-furan ring with the nitro group attached, and each of these structures have them. So furazolidone, furaltidone, nitrofurantone, and nitrofurazone are all detected as their respective marker metabolites, AOZ, AMOZ, AHD, and SEM. So one of the main aims of this work was to extend the scope of analysis to include additional drugs, and their structures are shown on this slide here. So this objective was met by adding in 4 additional drugs. So firstly, furacil was added as its marker metabolite DNSAH, and that was included because it was added to the monitoring list in the EU, and this ban came into effect in March 2003. Secondly, nifuroxazide was included in our method because it was identified as a drug that can result in bound residues in animal tissues in the form of HBH. A further 2 drugs, nifuraldazone and nitrovin, were included. So despite the fact that nitrovin isn't included on the EU monitoring list, it has been added onto the priority list for veterinary drugs in China. So we included that, and that can be detected as aminoguanidine, and nifuraldazone is thought to be able to be detected by its marker oxamic acid hydrozide. So, as I mentioned, parent drugs become rapidly metabolized to form protein-bound metabolites, and these can be monitored in 2 different ways, so bound analysis and total analysis. So bound analysis involves extensive washing with ice-cold methanol, ice-cold ethanol, and diethyl ether, and that serves to isolate the bound residues only, and it also removes matrix interferences. And this can lead to more sensitive analysis because you're injecting a cleaner extract, and this can lead to less instrument downtime as well. In contrast to this, the total analysis does not involve any sample washing. So that means that you are bringing forward the bound residues and the free residues through for analysis. And because the washing step takes a full day to do, because you need to leave the samples overnight for the solvent to evaporate, without this washing step, the total approach is much quicker. However, it can lead to less sensitive analysis because you're going to encounter more matrix interferences, and because you're injecting what's known as a dirtier extract, that can lead to shorter column lifetimes and more source contamination problems. So taking this all into account, we decided to develop a confirmatory method for looking at bound residues only. So the method developed in the Food Brand project kind of became the standard blueprint for bound residue nitrofuran analysis. And it's shown in this schematic here. So you start by weighing your sample, extensively washing it with solvent, and then it undergoes a hydrolysis and derivatization step in the form of a 16-hour overnight incubation in a water bath at 37 degrees Celsius. After this, the samples are neutralized before being extracted using a double liquid-liquid extraction with ethyl acetate. The solvent extracts are then evaporated to dryness under nitrogen before being reconstituted and injected for LC-MS detection. So given that one of our main aims of this method was to develop a rapid approach, I wanted to focus a little bit on the most time-consuming step, which was that hydrolysis and derivatization, and that takes place as a single step in the protocol. So the acid hydrolysis serves to cleave the bound metabolites from the protein, and then this released metabolite reacts with the NBA and becomes derivatized to form nitrophenol derivatives, which then go on to be detected. And this also prevents rebinding to the protein. So an example of this is shown here with the tissue-bound SEM that undergoes the hydrolysis with your hydrochloric acid, forming released SEM, which then goes on to react with nitrobenzaldehyde, which is your derivatization agent. And then that undergoes derivatization to form NPSEM, which goes forward for detection by LC-MS. So the aim of this research was to address some of the limitations of the conventional approach by extending the scope of analysis and also by shortening laboratory turnaround times. And these aims were achieved by adding in 4 additional analytes to form a method that detects 8 nitrofuran residues. And then the overnight incubation step has been replaced by a rapid 2-hour microwave assisted reaction. And the double liquid-liquid extraction has been exchanged for a Ketters-based extraction. And Ketters stands for quick, easy, cheap, effective, rugged, and safe. And it has the added bonus of being much greener in terms of solvent consumption. So all in all, this method reduces the sample turnaround times from 4 days to just 2 days. So I'm going to speak to you a little bit now about how we went about developing this method. And the first step was developing a liquid chromatographic separation for the 8 analytes. So the majority of methods that look to separate just the 4 main drugs use C18 column chemistry. So this was our starting point, but it became very clear that the C18 was just unsuitable for separating the 8 compounds from the matrix interferon peaks and also from each other. We trialed different mobile phase additives, different mobile phase compositions, and different LC gradients, but we were still getting unsatisfactory peak shape and unresolved matrix interferon peaks. So we had to evaluate different column chemistries. And because phenylhexyl chemistry is known to provide improved selectivity for compounds that contain aromatic functionalities, we decided that that was a good place to start. We assessed 7 different phenylhexyl-based columns and assess them on the basis of 3 different factors for resolution, column efficiency, and asymmetry factor. And on the whole, Agilent Zorbex phenylhexyl column was selected, and we were able to achieve full chromatographic separation of the 8 analytes. So when you're talking about separating analytes in solvent, that's one thing. But when you go to inject a matrix extract, you have to contend with matrix interferences. And an example of this is what you can see on the screen here. So the matrix interference that we saw in the window of NP-AHD. We developed the method on an extremely powerful and sensitive CIFSQ 5500+, and we were able to see lower levels than we'd ever seen before. But because of this greater sensitivity, we also were able to see unwanted matrix effects, like what you can see here. So the matrix effect, the matrix interferon peak is unresolved from the analyte peak, and this was affecting our quantitation. So we had to carefully select the different mobile phase additives, different mobile phase solvents, and LC gradients in order to sufficiently separate it. And here in the bottom figure, you can see how well resolved both peaks are. And we've shown this using an open acquisition here, but in reality, during routine analysis, that matrix peak falls well outside of our MRM window. So it has absolutely 0 impact on our quantitation anymore. So overall, we were able to achieve full chromatographic separation, which you can see here, using the phenylhexyl column at 40 degrees Celsius with an injection volume of 10 microliters. And it was over the course of a binary gradient across an 11-minute run. So that's kind of the streamlined version of how we came to this final method, but it was much more complicated than that, and we encountered many challenges, one of the biggest being column instability. So we had originally selected the Agilent phenylhexyl column to move forward, and using a different set of conditions and a different set of mobile phases, we got really good chromatography. And so we started to move forward into validation. However, it became clear where the column would just die after 10 or 12 runs, and it allowed us to see that the conditions we'd chosen actually were unsuitable for the column that we were using. So we had to go back to the drawing board and re-optimize our conditions in order to finalize the method that I'm presenting here today. And it's just a very clear indication that a lab has to be extremely rigorous when finding out whether a method is robust and repeatable enough before incorporating it into their test methods. So once the LC part was all sorted, we moved on to sample preparation. So as I mentioned before, a key step in nitrofuran analysis is the hydrolysis and derivatization, which takes place at a very time-consuming step, which takes 16 hours in a water bath. So we looked for an alternative way, and we settled on using a microwave-assisted reaction. We used all our developmental work using spiked material only, and originally optimized the method as a 13-minute reaction. We took this through all of our validation criteria, and it was passing with flying colors, and it was looking like this was a viable approach. However, that was until I got the opportunity to test some incurred material as part of a proficiency study. And as you can see by the chart here, a major issue was highlighted. You can see that the microwave reaction was only quantifying about half of what the water bath was. And it became clear that the microwave was just not sufficient when working with real incurred materials. We only were able to identify this issue because we got the opportunity to test incurred material, and that's not always a given. We originally developed using spiked material, mainly due to an availability of incurred tissue, but also because it was the done thing in literature. And also many proficiency studies also send out spiked material. And if that had been the case in this instance, we never would have identified this as an issue. So after discovering this problem, it led us to further optimization using AOZ incurred material. We quickly realized that the original method was only optimized for the derivatization of the analytes, but not the hydrolysis step. Because we were using spiked material, the residues were never bound in the first place, so we weren't able to see that issue. So we tested various different conditions as shown on this graph, and after assessing their impact on analyte stability, we settled on a 2-hour reaction at 60 degrees Celsius in the microwave as optimal. And since then, we have verified this and we are confident that it works with real incurred tissues. So once we incorporated all that method development, this was the final method that we were left with. You can see that the sample weighing, washing, and homogenization has stayed the same as the conventional approach, but the hydrolysis and derivatization has been swapped out for a 2-hour microwave-assisted reaction, and then the double liquid-liquid extraction has been exchanged for a modified Ketchers extraction. After this, the samples are evaporated, reconstituted, and injected for LC-MS analysis. So on the whole, compared to the conventional method, the sample turnaround times have been reduced by half, from 4 days to just 2 days. So once we had established this final method, it underwent full validation in accordance with the new guidelines set out in the 2021-808 European Commission legislation. And these guidelines are new as of this year. And one of the main changes are the lower validation levels that you are required to do your runs at. So our method met all of the performance criteria in terms of selectivity, linearity, matrix effects, trueness, precision, within lab repeatability, and within lab reproducibility. We carried out a multi-species validation, which meant that we incorporated samples from avian, bovine, ovine, and porcine species in our validation runs. And we also included a select few cervine and equine samples as well. So after this rigorous validation, we were awarded accreditation by INAB, which is the Irish National Accreditation Board. And this basically confirms the integrity and the conformity of the method to be included for routine analysis. So this slide here is just a very brief summary of some of our validation results. You can see that the within lab repeatability was carried out at 3 levels, which were 0.25, 0.5, and 0.75 ppb. And then the reproducibility were carried out at 4 levels, and the extra level was at 1 ppb. And you can see by the values here how true and precise the method is. Also displayed on the table are the CC alpha values that we calculated. Each of these values were verified in a CC alpha confirmation run, whereby different muscle samples from different species were spiked at the CC alpha levels, and we were able to confirm that we could indeed see them. So each of these CC alpha values fall well below the 0.5 RPA that is set for nitrofurans. So as I previously mentioned, it is incredibly important to be able to apply your method to incurred tissues in order to confirm fitness for purpose. So this method was applied to 7 different proficiency materials, which were incurred with either SEM, AHD, AOZ, AMOZ, or DNSAH. And each of the samples were from a range of different animals, including chicken, pig, and turkey. In proficiency testing, a Z-score that falls between -2 and +2 considered satisfactory. And as you can see on the table, each of our proposed Z-scores fall well within that range. So One of the new drugs that it's included in the method is nitrovin, and we are detecting it as its proposed marker aminoguanidine. And several different methods in literature have included aminoguanidine as the marker, but it has never been confirmed as a product of nitrovin metabolism using animal studies. So as part of this research, pigs were fed nitrovin medicated feed, and then muscle, liver, kidney, and plasma samples were collected. These samples were tested, and each sample came back as positive for aminoguanidine. And this was the first instance that we were able to confirm that aminoguanidine is a product of nitrovin metabolism and can be used as a marker metabolite. We also used some of this material to be able to demonstrate that the microwave and water bath derivatization processes were equivalent when applied to nitrovin incurred material. And you can see on the chart here that they did have equivalency, confirming yet again that the method is fit for purpose when applied to different incurred tissues. So finally, the method was applied to a poultry retailing sampling study, whereby 118 different poultry products were analysed. These products comprise chicken, turkey, duck, and quail. They were purchased from different supermarkets across Ireland, and they each had different countries of origin. Each sample were found to be negative because no nitrofuran residues were detected. However, this isn't really a true indication of nitrofuran use in poultry across the world because of this. We have such a small sampling size. It's only really giving us a snapshot representation of poultry at this certain point in time. In order to be able to get a clearer insight into potential nitrofuran misuse, we would have to analyze a much larger group of products. What the survey does tell us, though, is how robust our method is. It was able to analyze 118 different poultry samples that were both processed and unprocessed, and we ran into no issues at all, meaning we didn't have any matrix interferences come up, and we also didn't run into any instrument downtime. So just to conclude, a rapid and improved method has been developed for the detection of 8 nitrofuran residues by incorporating a rapid microwave assisted reaction and a Ketchers-based extraction. So our aims were met in this research because we were able to extend the scope of analysis, and we were also able to shorten laboratory turnaround times from 4 to 2 days, making nitrofuran analysis much more efficient. It has now been included as one of the official accredited methods for testing nitrofurans in the National Residue Control Plan in Chagas Food Research Centre. And I've hopefully also highlighted during this presentation the importance of holding newly developed methods to extremely high standards when determining their fitness for purpose. By doing this, we're able to identify any shortcomings and also confirm equivalency to existing methods. The development of a new method can be a very long and challenging process, but it is extremely worthwhile because it allows us to make the developments and advancements necessary in order to keep up with the extremely fast-paced and dynamic nature of our food industry. So just lastly, I would like to acknowledge all of the staff in the National Reference Laboratory here at CIFSQ for their help and support during this research. We'd also like to thank the staff at the EU Reference Laboratory at Fougères in France, because they supplied incurred material to us that was absolutely essential when evaluating the method's performance. And we'd also like to thank those at AFBI in Belfast for their work in producing nitrovin incurred material, and also for their help during interlaboratory studies. So thank you for your attention.
Many thanks, Gemma, for excellent presentation. So I think what Gemma has just presented is probably the biggest advance in nitrofuran residue analysis in about 20 years. So it's a major, major step forward. And it is my belief that this method will be used not only in Ireland, not only in China, but will be uptaken by many, many different countries in the world. So many, many congratulations for that. I think it's also very important to pick up what Gemma said about the way that the method was validated, that the need for incurred materials was hugely important, and never always rely on spike materials. So Gemma, thank you very much, and many congratulations again.
Thank you.
It's my pleasure to introduce our next speaker, and on the theme of working for Chagas, and also on the theme of being a PhD student at Queen's University Belfast. It's my great pleasure to introduce Clément Doulier from EU China Safe Project, and also keeping on the theme of mass spectrometry and detecting drug residues in poultry. Clément is going to give us a presentation about the detection of antiviral drugs. So Clément, over to you now, and we're looking forward to hearing your work.
Hey, thank you very much, Chris. Hey, I'll share my screen now if you can see it. Yeah, is that all right?
Not yet, Clément.
Yeah, sorry. Should be okay now.
Perfect. If you just go into display mode. Perfect. Thank you.
That's great. Thank you. Hey, hello everyone. As Chris said, I am Clément Doulier. I'm a PhD researcher. I am based in CIFSQ in Republic of Ireland. I'm happy to be here to talk to you about my research, which is the development and validation of liquid chromatography coupled tandem mass spectrometry method for the quantification of antiviral drugs against influenza. So during this presentation, I'll go through the context of my research about influenza, avian influenza, and what is the big scale issue about using antiviral drugs in poultry farming. Then I'll go through method developments on the LCMS part and the sample preparation development. Then I will describe the method performance and how I have validated these methods according to new guidelines. Then the application of the method, and finally I will conclude this presentation. About influenza, I think pretty much everyone is familiar with influenza, but in humans there are three types, A, B, and C, and A and C are also common to other multiple species. The common symptoms of human influenza are fever, headache, dry cough, nasal congestion, and for vulnerable people it can lead to more complications across different organs, and it can actually lead to serious illness and even death. So we know the influenza on the seasonal epidemic form, which is causing up to 1 billion infections per year and causing up to 500,000 deaths globally every year. But a more worrying aspect is also the pandemic form that comes from the emergence of new strains that are so different from previous strains that the immunity is low, and therefore these new strains are very dangerous and can cause big troubles on the pandemic scale. So, for example, the Spanish flu in 1918, caused between 25 and 50 million deaths. And actually, researchers suggested that all the past major influenza pandemic were caused from zoonotic origins. So, speaking of which, avian influenza is an example of this. And there are regular avian influenza outbreaks in the poultry industry, but also in wild bird species. There are constantly the emergence of new strains, and we know the H5N1 that has been spreading since 2004. But for example, very recently, this summer of 2021, there are a new strain transmissible to human, which is H10N3. The big problem with it is that a combination of avian influenza, which is highly pathogenic, with human influenza that is by definition transmissible between humans can create a new virus that is both highly pathogenic, and also transmissible between humans and to humans. To treat influenza, several drugs have been developed, and they have been developed and designed only for human. And despite being not licensed for animal producing food, there has been some detection of antiviral drugs such as amantadine in poultry. So as a consequence of this, the Chinese and the US authorities have banned the use of certain antiviral drugs in poultry farm. This includes amantadine, which is the most common residue found. And therefore, on the analytical side, there is a necessity of developing analytical methodology to detect the illegal use of these drugs. Actually, there are already existing fast screening techniques. So these are techniques that are focusing on only one or two compounds, and they are extremely fast and sensitive, but the problem, as I said, is that they focus only on one or two compounds that are molecularly similar. And at the end of the road, analysis is always needed. These methods already exist as well, but there are two issues with these methods. First issue is that they don't include all compounds of interest, namely the polar molecules that are the most challenging, that poses the biggest challenge to the analysis. And another issue with other methods is that they are very, very long and very complicated. So, for example, on the right, you can see that sample preparation for this for this method is to use two solid phase extraction cartridges as well as two analytical columns. So the procedure is long and complicated. From this, there are two goals to my method, which is to encompass all the relevant antiviral drugs, and as well to produce and develop a method that is easy and accessible. So for my method, we have selected 15 antiviral drugs that are classified according to different family, depending on their mode of action or on their chemical structure. So for example, we have neuraminidase inhibitors with the most polar compounds such as zanamivir and namivir, oseltamivir and its metabolites, and as well as peramivir, which is a much newer drug. We have much older drugs that are tricyclic amines that have been licensed since the 60s, and such as amantadine or imantadine. We have ribavirin and its prodrug variamidine, and we have fusion inhibitors, arbidol and its metabolites. And finally, we have favipiravir that is also used for HIV. On top of these 13 influenza drugs, we have two additional antiviral drugs that are ganciclovir and acyclovir. That these are actually drugs used against herpes. So to understand the analytical challenge, we have to have a look at the properties of these compounds. And first and foremost, the biggest challenge is from their polarity. There is a big gap between the most polar and the least polar analyte. The most polar is zanamivir on the left with a polarity index of -6, and the least polar is arbidol with a polarity index of 4. This is a big gap, so it poses a big challenge for the analysis later. These are also acid, basic, and neutral compounds that leads to cationic and ionic or neutral form in the whole pH spectrum. So this broad range of compounds makes the analytical method challenging. These are all drugs treating the same disease, but the issue is that their mode of action is focusing on different reproduction step of the virus. So therefore they are very different molecules. To develop this method, we have used LC-MSMS, meaning liquid chromatography coupled to tandem mass spectrometry. For our instance, we used water acuity I-class coupled with the Xevo TQ-XS for the MS part. So this instrument was highly suitable for our application because on the LC parts, we are able to separate the compound of interest from the matrix. And for the MS part, by selecting the right parents and the right daughter ions, we can have a very good selectivity. This instrument was also very sensitive and can allow to detect antiviral drugs up to a 0.1 microgram per kilogram of poultry meat. So the first step of the method optimization was the mass spectrometry, and we could compare two sources of ionization, which are electrospray and unispray. They both nebulize a liquid flow using a high flow of nitrogen, but unispray, as you can see on top right here, has a slightly different mechanism. It is using an impactor pin and to which high voltage around 1 kilovolt is applied, and this can redirect the flow to the cone. For the case of our application, electrospray gave better sensitivity at a smaller flow, and it was also better using higher proportion of organic solvent as a mobile phase. So we decided to go with the electrospray. This was simply the best option. Following this, we have optimized the source parameters, and most suitable transition was selected. And for example, the water loss transition that are not non-selective were avoided when possible. Positive mode and protonated molecules for all compounds were found also to be the best option. Now on the chromatography part, the first step of the chromatography development was to try the C18 columns. So we tried a wide range of C18 columns because they are the most common reverse phase and the most common columns that are used. So what we found that experimenting this is that little to no retention was found for most polar compounds such as zanamivir or ganciclovir or ribavirin. You can see on these two examples that they are almost not retained at all. So this was a big issue, and the conclusion was that C18 is obviously not adapted to polar analytes, or highly polar analytes, but also not compatible with our application. Other reverse phase options were alternative reverse phase column with alternative phase. So these are, for example, phenylhexyl or diphenyl or PFP or PFPP. These are different phases that are a bit less hydrophobic than C18 and can give the best retention for polar compounds. we found actually that, as you can see on this radar plot, that Selectra PFPP gave really much better retention time and retention factor for ganciclovir, zanamivir, ribavirin. However, the retention was still considered as low, and we've tried to improve it by the use of ion pairing and such as HFBA, which worked actually quite good, improved the retention a lot, but ion pairing was still not chosen because it was not practical in terms of source contamination that can prevent multiple application on the same instrument. So the best option that was finally found for the chromatography was HELIC. HELIC is hydrophilic liquid chromatography. And it was simply the best chromatography mode for polar compounds because it has two kinds of mechanism, which are ion exchange or partitioning between organic solvent or aqueous solvent. And we found while screening different columns that ion-driven columns, ion exchange-driven columns, were not the best because ribavirin, being neutral, for example, was absolutely not retained. So we have to go for partitioning mechanisms such as helix Z, as you can say, or as you can see, or BHMide. And BHMide was found to be best because it could retain better the early eluters such as Arbidol or favipiravir, could retain it better than helix Z. So we finally chose to go with this column, and we chosen the formic acid as well as ammonium acetate as additives because they were the best compromise between good peak shape, good retention on the chromatography side, and on the mass spec side, they were the best option or best compromise, at least for appropriate ion suppression. When comparing reverse phase and HELIC, we can see for most of the most polar compounds, the ion suppression is huge for Selectra PFPPs, which is here representing reverse phase. And we could find much better ion suppression results with BHMide. This is explained, as you can see on the bottom right, by the huge suppression zone for a zanamivir that is happening in just before a minute in its elution zone. So this confirms our choice to use a BHMide as a column. On the sample preparation side, we have tried several options, I may say, and we kept in mind that we wanted a fast method. So we first tried catchers that is widely used for veterinary drug residue in food analysis and in meat analysis. And we found that it was really ineffective for highly polar compounds, as the most polar compounds, again, were trapped in the aqueous phase and extraction efficiency was very low. Instead, we went for a classic solid liquid extraction protein precipitation using acetonitrile, methanol, and hexapropanol. So these are all solvents that we tried, and we found that a mixture of acetonitrile and water, 80-20%, was the best overall for two reasons. First, it gave satisfactory or best extraction efficiencies, and then the extras were relatively clean to compare with other options. Keeping in mind, again, we want a fast method. We've tried several cleanup techniques, And first, one of them was ultrafiltration, 3000 Dalton filter, for example, cutoff filter. And we found that they did not provide any additional cleanup and did not clean additionally the primary extracts that to compare with the protein precipitation. Another option was freezing step, and that is used usually to remove lipids from a matrix. And we found that the polar compounds were trapped in the ice, and therefore the extraction efficiencies were again very low. Finally, we've tried a DSPE solvent, so dispersive solid phase extraction solvents, such as C18, ZZ+, or PSA. And we found that in terms of matrix effect, there was no to little benefits, and it was not worth it simply. Instead, we went for a dilute and shoot method where we just diluted the primary extract, and it could allow us to do some kind of solvent exchange and have the solvent injection as we require. So which was acetonitrile, methanol, water at 50%, 25%, and 25% respectively. So our final method is simply weighing the tissue and then extracting with 80-20 acetonitrile water and then diluting it with the solvent I've just talked about. Then filtration and then injection into a Helic MSMS system. After developing the methods, we've validated it according to a new EU guideline 2021-808. So the repeatability runs were done across 3 days, and each day 21 aliquots of the same poultry sample. Then the reproducibility assays were done over 63 different poultry samples. So it included a duck, chicken, and turkey as well. So all criteria for this validation were validated, and you can see on this plot that 84% to 127% results were for the trueness in reproducibility, and as well as 2.8% to 22.7% for the precision and reproducibility. The linearity criteria was also validated during this step, and for our calibration curve, we had 8 levels, matrix match calibrants, and also a 0 level. So we could build a 9-point calibration curve with this. All coefficient on determination were judged to be satisfactory because they were above 0.988, which is quite good. The LOQ that we found, limit of quantification, range from the most sensitive compounds at 0.03 microgram per kilogram up to around 10 microgram per kilogram for favipiravir. After validating these methods, we have put it into application across 120 poultry products that we collected from shops on the Irish market exclusively. So these were a mix of either EU, UK origin or outside of the zone. That could be in Asia or from South America. And these were a mix of cooked and raw products or processed products. And what we found is that we found no trace at all, at least on these 120 poultry products of the Irish market. No trace at all of antiviral drugs residues against influenza. In conclusion, we have developed an LC-MS method for the confirmatory quantitative analysis of 15 antiviral drug residues in avian muscle. And this method is much faster and easier to compare with previous methods. And this will greatly help to detect the illegal use of these drugs in poultry farming. So thank you to everyone participating to this project and helping me, and thank you for your attention.
Thank you very much, Clement. Excellent presentation. I think again, outlining the importance of not only the method development, but the validation, the huge amount of validation work that you have done. And I do believe that this method, again, something that has been produced by the EU-China Safe project, will find its way into many different regulatory testing regimes in different parts of the world. So many, many congratulations. And I know, Clement, you're just about to submit this for publication. So very best of luck. And I think you'll have that accepted without very many revisions. So congratulations on fantastic work. So what we'll do now is we'll move on to our next speaker, and our next presenter is Garino McConey from UCD, from University College Dublin, another partner in EU-China Safe. And I think what's very important about this is the work that Garino was going to talk about. It's not something that we had planned. It's something that we envisaged at the start of EU-China Safe, but became hugely important during the last 2 years when we've been faced with the global pandemic. And again, I think it's a wonderful example of how there's been a massive amount of exchange of scientific knowledge, of expertise between European partners and Chinese partners. So Garino, over to you, and we all look forward to hearing your presentation.
Thank you very much for the kind introduction. Hello, everyone, and good afternoon to all the colleagues in China, and good morning for who is in Europe. I'm a research scientist, molecular microbiologist as a background, and bioinformatician in UCD at the School of Public Health, Physiotherapy and Sports Science. I'm very pleased to be here today with all these fantastic speakers representing the Centre for Food Safety at the University College Dublin, Ireland. And the center is located in one of the largest buildings on campus at the O'Brien Center for Science, you can see here in this picture. And CFS is part of the Institute of Food and Health. UCD CFS is now recognized as an academic center of excellence in food safety research, and has as director Professor Seamus Fanning that was responsible for the project. The piece of research we present today was part of the China Safe with the aim of produce standardized protocols for the application of techniques for sequencing, in particular whole genome sequencing analysis that can be used as a method for supporting the investigation and detection of food fraud and improving food safety, as well as increased traceability and transparency of global supply chains. In this frame, the sequencing technology has had a huge impact to meet the aims of the project, and we have developed a series of standard operating procedures shared with the partners of the project and scientific community in dedicated platforms. And we also ran a laboratory exercise as a ring trial, sequencing 22 isolates in different research units, and validated the accuracy of sequencing and the good application of the protocols. In addition, as Professor Elliott mentioned before, so the global pandemic had a huge impact on the exercise, but we took advantage of this tough time to share protocols indeed for the detection and studies of SARS-CoV-2 virus in different laboratories, partner of the project EU-China Safe. And today, I would like to share with you the output of a parallel research project that was run in our laboratory during the pandemic and represents a good case study for future collaboration, I guess. The project was funded by the World Health Organization, and usually the greetings go at the end of a presentation, but this time I really want to say thanks to everyone else. First of all, Prof. Fanning, who had the intuition of initiate this effort, this survey, and then shared the output immediately with the colleagues of the China Safe project. And thank for the help of many people affiliated to the Center for Food Safety, Lauren Russell, Francisco Rodriguez, and Alex Floss, and also who helped with the preparation of the samples and validation of the procedure, so Siobhan McCarthy and Charlene Bennett. Here, just a bit of background on the topic I will present today. The virus SARS-CoV-2 is now well characterized, even though it's not described the possible carrier yet, but were considered the animal which transmits the agent, but other animals and events are now considered as a possible source of the virus or the possible starting event of the transmission. And there was no evidence in the role of domesticated food producing animals and the meat derived from them, and also the associated processing environments. All these unknown scenarios represented a public health challenge, necessitating the development of suitable diagnostic protocols. In terms of implementation of intervention measures along the food chain, and in order to recognize as well the possible transmissions routes. Now, the disease is easily transmitted and spreading from person to person via cough, sneeze, respiratory droplets, or close contact with infected people. And for this reason of concern were processed foods and food packaging, wherein the SARS-CoV-2 could reach consumers following the cross-contamination. And during the peak of the pandemic in Ireland and internationally, some essential workplaces were completely affected, specifically the meat processing plants. They were proved vulnerable to outbreaks of COVID-19. For example, a major outbreak in a German meat plant resulted in more than 1,400 of 6,000 employees becoming infected. And in Ireland, unfortunately, we had similar data in different meat plants around the country. And the aim of the project was to provide data on the detection of SARS-CoV-2 in selected food matrices and in selected food processing environments, and the consequential genetic study of the viruses recovered, with the aim of tracking and also making public the data in available databases. For doing so, the 3 months plan was divided in 2 pieces of research. So we had the first, that was a survey on the identification of SARS-CoV-2 RNA in foods. And this was made using reverse transcription polymerase chain reaction. And the second part included the characterization of positive samples by whole virus genome sequencing for this comparative analysis of these viral strains with those that were available globally. The first piece of work was to find and understand as well the size of the samples that were representing the, in terms of numbers, the food chain. So it is not really easy to design a plan for a short time and delivering results that are meaningful. And there are different models, and we decided to proceed with a pragmatic approach and providing qualitative results. Indeed, the presence or absence of the microorganism in a sample, and in this case, the virus SARS-CoV-2. And we use the confidence limit of 0.99 and 0.10 as the upper confidence. That was the approach that we finally choose. And a number of 51 samples in 20 days per matrices was included. We considered different samples. We had food samples, and in the specific, we plan to sample raw meats, vegetables, fruits, and then as abiotic surfaces of high touch locations, for example, the air conditioning units, taps, door handles, And also in the same processing plants, we included the sewage samples that could have given a track of the presence of the virus on the sites. And this was demonstrated as an approach by different studies, including the SARS-CoV-2 in sewage and bodies of water led by Professor Wimmeyer and Nicola Fletcher here in UCD. In total, in 2.5 weeks, we have sampled and tested 105 raw meats, 101 fresh ready-to-eat vegetables, and 157 fresh and frozen ready-to-eat fruits. Just to give an idea of the type of food we sampled, I reported here the plots representing the data breakdown. For instance, we sampled poultry and pork, which included pork mince, sausages, and also organs and fillets. For seafood matrices, we sampled oysters, which have the characteristics to be eaten raw, and also mussels and other mollusks, prawns, and shrimps. In terms of vegetables, we had a mixture of ready-to-eat and matrices that are eaten cooked. And finally, we concentrated the sampling plan on fruits that are mostly coming from different parts of the world, and usually 8 raw. And in addition to the food samples I just mentioned, so all the packaging was included and tested as surface swabs. And also were included the skin of bananas as swab samples for a total of 367 samples. We included as well RNA already extracted and stored in -80, representing pork meat and small fruits collected between January 2018 and December 2019 for a sort of retrospective study. For what concerned the abiotic surfaces, we developed a kit for companies for safely sampling with swabs and the collection of wastewater that were collected twice from the line of untreated water, including wastewater from building use. And we provide as well the protocols to these companies in order to safely proceed with the sampling. We analyzed in total 75 samples of swabs and 6 water samples from sewage. Here, an idea of the type of samples that we have collected and tested in terms of swabs. In terms of methods, we use 3 different approaches according to the procedure suggested in available regulations for similar RNA viruses and type of matrices. Taking into account the possible inhibitors of the samples and using different approaches to evaluate the recovery of the virus and the inhibitory effect indeed. So for example, mollusks bivalves are considered not an easy matrices for the conservation of the virus outside the intestine, for the presence of inactivating enzymes and the possible inhibitor of the PCR. And also recovering the required amount of sample useful for the analysis is not easy and requires experience and time. We have included as well another important piece of research. We didn't want to leave only a present-absent risk of the food chain for this virus, which was anyway the mandate of WHO. We thought it was more valuable studying as well other sectors and also test with a more pragmatic experiment the survival of the virus on different food matrices. And if we are able to detect the virus at different concentrations, store temperatures, and also sampling times, mimicking what the food chain is in reality, where we have the transition of food in a so global market from different continents. So we came up with this strategy in collaboration with colleagues at the School of Veterinary Medicine at UCD. And this experiment included experimental spiking of packaging pork and meat with a quantified number of viral particles that were then stored at refrigeration and frozen temperatures and then the recovery of the virus during the study to see the infectious and the vital viral particles present in the still present in the samples. For the RNA extraction, we used an automatic handling system, and for the reverse transcriptase PCR, we used the QuantStudio 5 machine. Then again, as a controls, we used plasmidic DNA and RNA from positive clinical samples, and also Mango virus as process control that allowed us to evaluate the recovery that was excellent for 1,261 samples, so all the pool of samples that we tested. The RNA of samples tested positive by molecular methods are the templates for the reverse transcriptase, where we generate the molecule of DNA from a copy of RNA and then prepare the samples for the sequencing machines that will give back the results. These are then analyzed with bioinformatics tools to reconstruct or assembling the whole virus genome sequence. And the approach for the preparation of the samples is called tiling PCR. So it's a tiling amplicon where the cDNA is amplified with a set of primers that generates amplicons of 400 base pairs, here indicated in blue in the figure. And these are then the amplicons and the tiles covering the whole genome of the virus that is colored here in orange. So the amplicons are then prepared for the sequencing, and the data generated are then again analyzed to reconstruct in silico the genome of the virus present in the original sample. And during the emergency, we consider to develop approaches as well for facilitating a prompt molecular diagnosis of outbreaks in food-producing plants. And I would like to mention as well the method that we developed in collaboration with the Department of Agriculture, Food and the Marine for extracting the viral particles from positive spent rapid tests. In fact, with this method, we were able to obtain high quality viral RNA and proceed with the direct sequencing, avoiding in this way the second swap from tested positive. And this is an extremely useful strategy for detection of variants and tracing outbreaks, and of course, surveillance, and maybe could be the system that we can use for future outbreaks. So in total, as I mentioned before, so we tested 1,261 samples using different controls as positive samples and controls for of the process. And the samples were extracted and tested in pools of 10 units. And we tried to keep the limit of detection very ample in order to apply a sort of precautionary principle. And with this approach, 4 pools resulted very close to the limit of positivity. And for these reasons, we decided to test the single RNA extracted from each sample, and we compared as well these samples with nucleic acid extracted again from the original matrices that were stored frozen during the 2 weeks of analysis. In fact, the extraction from original samples was repeated, and all the samples likely, so they were resulted negative. And I'm glad to already present the first parallel study for testing the viability of virus particles on foods in collaboration with Professor Gerald Barry and Tristan Russell at the School of Veterinary Medicine here in UCD. Here is presented the result of the viability of the virus on salmon, and you can see that the concentration of vital virus remains high at -20 degrees, the orange trend here. And while there is a decrease on the logarithmic titer after 6 days from the contamination when the samples are stored at 4 degrees. This is represented here with the blue lines and dots. And hopefully we will be able to publish this data soon, including the recovery of the virus particles in different matrices and food packaging materials. So this, in also in the opinion of the group, will be an important support for policymakers in addition to the results that we found testing more than 1,200 foods or food-related matrices to define how the food chain is safe. However, even though we are able to detect the virus on packaging or feedlets, as happened with the salmon, and these can generate a cross-contamination, we need to keep in mind that the risk of getting sick or infected by SARS-CoV-2 by eating or handling food, including frozen food, ready to eat, and food packages is considered very, very low. Now, I want to present something a little bit different to explain the importance to place measures in different environments. And as we all know, a virus mutates, and the variants occur, and a virus wants to be able to get to the next host to be able to make more of itself, basically. And that's all a virus cares about. There are, of course, different paths that can be followed for novel mutations. And this was also the principle of the core of the project I've just presented. In order to understand the genomics of the virus potentially involved in foods in the case of detection. Now, if we have the sequences of different viruses, we can detect the variation on their genomes. So the SNPs that can happen when there is a mutation, and compare them to each other's and also with other globally available sequences. With the possibility to connect cases, outbreaks, and also the direction of the infections. So during the first wave of the COVID-19 pandemic, I volunteered at the microbiology department in St. Vincent's Hospital, helping to setting up the molecular laboratory for the detection of SARS-CoV-2 with other colleagues from UCD, including Dr. Yvonne McCabe and Professor Fanning. As soon as the tests were available, also for the patients, we noticed several outbreaks in different wards. This was observed in different healthcare institutions and, unfortunately, also nursing home all over the world. Testing was not well spread, and there was a shortage as well in terms of reagents. Testing was applied. In addition, due to the limit presence of evidence, the guidance on appropriate infection prevention and control measures, such as the wearing of face masks, varied from institutions and states. In St. Vincent's, between March and April 2020, were recorded many positive cases on ward patients. And on the 24th of March, the in-house SARS-CoV-2 PCR for healthcare workers as well was available. And as you can see here, small outbreaks were recorded in different wards, represented with different colors in the figure here. And as you can see, here this is the axis with the representation of the positive cases along the time. But while at the first week of April was introduced the measures of wearing surgical masks for healthcare workers as well, and we were suspecting a transmission more subtle from asymptomatic positive individuals. And what we decided to do, it was to check with more details onto these samples using a sequencing strategy to better understand the genome of the viruses involved on this case and see the relation among them. And at the time, there was no validated protocols, but at the laboratory at the Center for Food Safety, we were using the sequencing approach for many applications, and we put in place the method and generated the sequences for 50 samples that at that time was considered an enormous effort for the hospital last year in March. I reported here a few definition and criteria for selecting the samples, which included healthcare workers and hospital acquired cases. And we included only patients that were hospitalized for more than 14 days for taking into consideration the full incubation period of the virus. As I mentioned before, the mutations in the genome is what make the strains different. And considering that a virus mutates during the time, we were able to detect these differences among the 50 samples and also order the infections chronologically. So the first step was aligning the genomes, as you can see in this figure here. So you can see each line, which is a different sample, and we detected the differences represented by different lines. And we generated that what we call a phylogenetic tree. Here we have different colors with the different words. And if we look in more details, we can see there are groups that we call clusters, which indicates that the different samples contain viruses with genome very similar in the order of very few mutations, if not the completely same genomes within the same group or cluster. The patients were infected almost at the same time from the same source. And each group is connected with different healthcare workers. So you can see here the highlighted lines, and the healthcare worker were they were close contacts with a group, and they were completely asymptomatic. So with this study, with the study, we demonstrated the importance of use surgical masks, because it was not mandatory at the time, and the need as well to restrict healthcare workers' movement across different wards, because we have as well this kind of phenomena. Finally, I want to introduce another study. We are now part of a large consortium of brilliant scientists in different institutes, and part of a structured study funded by Science Foundation Ireland for understanding and preventing the outbreaks of COVID-19 in meat processing plants. The project is coordinated by Professor Grace Mulcahy and funding with different working packages, where the main goal is to understand the reason why the outbreaks were and are so prevalent in the meat plants, and also find ways to control, detect, and also study the virus efficiently. This approach can be then applied in different industries and also in different contexts and other pathogens or diseases in the future. And of course, the EU-China project has been a precursor, in my opinion, for this approach. One of the main goals of the working package that I'm coordinating at the moment is to evaluate the performances of a recently developed massively parallel diagnostic assay platform, with the aim of releasing a robust protocol for the analysis of next generation sequencing amplicons, which workflow is well represented here in this in the figure in the slide, and include viral RNA extraction. We have barcoding and PCR amplification, and then next generation sequencing to quantify the amounts of barcoded cDNA synthesis products that are the template of the process. The aim of our research is to apply this approach for many other infectious diseases and markers that have an important interest for public health, such as, for example, detection of antimicrobial resistant genes, but also, mixed population, and in order to predict the phenotypes of microorganisms, even in food. And so this is going to be a very important support for food safety and quality of products. And if there are researchers interested in collaborating with this project, I will be very happy to discuss further. But with this, I want to thank again all the people involved in the studies I've just presented, and the director of the Center for Food Safety, the staff in the laboratory at CFS at the University College Dublin, and many others, and of course the institutions who funded these researches. And then again, thank you very much for the opportunity to present this piece of research, and I will be very happy to answer to any question you might have also by email. But for now, thank you, and keep in touch.
Thank you very much, Verena, for an excellent presentation, an excellent overview of all the work that you and your colleagues have been doing for the past 2 years, I guess. And when we think about it, as the pandemic started, and then some reports started to hear about potentially food as being one of the important vectors for the virus, it caused a lot of concern, a lot of issues. And I think that your work and the work of other people have really helped reassure people that the risk of food transmission is very low. But again, I think it's just down to actually keeping people safe from the virus who handle food products like everything else. So I think many congratulations to you, your colleagues, for the work. And I think the work in terms of EU-China Safe has been really fantastic in terms of exchange of knowledge and exchange of information. So thank you very much for that.
Thank you.
So when I think about our session so far, we've had 6 speakers from 6 different countries. We've now got our 7th speaker joining us. And also to say that my next speaker, Moira, has trained me more than anybody else in thinking about things in relation to equality and gender. So just to let you know, Moira, we've had 3 female speakers and 3 male speakers. So you have me extremely well trained. But also what's very important is, I think working with Moira for so many years has been the importance of understanding that natural sciences and social sciences should work much more closely together. We can do science, but if we don't convey that information to the consumer, to the general public, it's a massive waste of time and effort. So Moira has really led a lot of the work in EU-China, looking at what consumer perceptions, consumer experiences have been both in China and in Europe. So Moira is going to give us a presentation about enhancing European trust in food and using garlic as a case study. So Moira, over to you now. Thank you. And we can see your slides perfectly.
Thank you, Chris, and thanks for the introduction. I also would just like to say to the previous speaker, it was an excellent presentation and I learned quite a lot about safety in the kitchen. And I will be taking that forward from your findings. So thank you for that. So my talk is very different. As Chris explained to you, we are interested in the consumer, the person who's going to use all the food products that has been produced. And one of the things that we have been working in EU-China Safe is how the consumer in China and the UK and Europe work in relation to their food, how they feel about their food, where their food is coming from, and how we can enhance the trust in the food that they buy. So, as you know, China has become one of the EU's biggest trading partners. So we do a lot of trade. But one of the ambitions of EU-China Safe was to see, could we enhance this trade through cooperation, harmonization? But we know in relation to food, there has been some food fraud incidents, both in China and in Europe. And this has made consumers a bit untrustworthy about the food that they're eating, as well as the producers. So we wanted to understand what is the need in terms of consumer trust and how our best way to enhance the trust, not only in locally produced foods, but also food that are coming from other countries. So what you would say, okay, fine, but why did we choose garlic? Well, herbs and spices are becoming very important and very popular in our food. Now, it has always been so. There have been spice wars, if you like, in days gone by, but currently is one way of enhancing food taste, enhancing ways of cutting down things like salt by adding different spices, but also it's where food innovation sits, how to make interesting, exciting dishes that are of value, of interest, of health to the public. So herbs and spices are very valuable commodities, but the supply chain is quite complex. So therefore, there are a lot of opportunities where fraud can happen, especially when the spices get processed. So we are going to look at garlic. I will explain why, and the different ways that garlic can get adulterated, if you like, once it's been processed, would be like adding talcum powder, chalk, and so on. So China is a major world producer of garlic. And in the EU, we don't produce the amount of spices that we want to eat and enhance our food, and therefore we need to import them. And then, for example, Germany imports a lot of its garlic from China. So we wanted to understand, do the European consumer understand where their spices and herbs are coming from? And if they do understand, how do they feel about it? And if their trust, where is their trust lie? And can we find ways of enhancing the trust? So why do we want to know that? So if you look at the table or the graph here, that shows you the exports and imports in relation to China and Europe. And as you can see, we do import a lot from China, but in relation to the food, which is the red one, we export more than that we import. So therefore, there is a market there for China to enhance and do more trade with Europe. But we need to understand, how do the European consumer feel about the foods that is coming from China? We know that as Europeans, we know and we understand a lot of electronics, a lot of other stuff that commodities that come from China, and we are very happy. But what about the food? What about the producers? And what about the manufacturers of these food? Now, we have done some work in Europe about how to enhance trust using technology, so that people understand, they can trace where their food came from, and also they understand about authentication. So we have worked using these various different technological tools in relation to beef, pork, oregano, and so forth, in relation to the European consumer. But we wanted to know, could we replicate, could we have the same effect on the European consumer when the food is not coming from EU, but coming from outside the EU? So therefore, our aim is to understand EU consumers' views and attitudes towards Chinese food product, in this case, processed garlic, and investigate ways of enhancing European consumers' trust in Chinese food produce. In this case, we are using processed garlic as an exemplar. Right, how did we do it? We did an online survey in Germany and UK, and I explained to you why Germany was one of the countries that we chose. Quite a big sample, about 300 from each country. And we needed people who actually purchased garlic, not in the clove form, but a processed form. And they had to buy it reasonably often, so that it was part of their cooking process, and therefore they would be interested in buying this product. Then we asked questions relating to different things. One, we asked about their buying habits, but also we wanted to know, when you look at the product, what kind of label would you like to see? And we gave them various options. We asked them, how much do they trust the garlic that they are buying at the moment? Okay, if it came from China, about the product as well as the producers. And then we asked them about the garlic that we are going to have that is traceable, that is authenticated. How much, do you like this? What do you think about it? What is your intention to buy? How much extra are you willing to pay? And then we asked a little bit of questions about them. So first we are in relation to trust. So we asked trust question, the products that you buy now, how much do you trust the garlic, the producers, the manufacturers? Then we showed them this particular garlic. So this is a traceable garlic powder grown in China. It has got a QR code, and you can scan the QR code and you can get more information in relation to traceability in terms of authenticity. Okay, this is not on the market at the moment, and we are investigating, if such a product came on the market, how would you feel about it? In relation to traceability, we told them where it was harvested, processed, packaged, and they can follow the journey. And we also said this information has been obtained using high-end tracing technology. In terms of authenticity, we have said that this has been trademarked, if you like, that it's verified as an authentic garlic product, and the technology behind it was fingerprinting technology. So this is the extra information that they got. They could see from this product, and then we asked them a series of questions about trust and about other things. So going back to the results, when we asked people, do you know, when you buy your garlic, do you actually check where it's coming from? We found about 80% of people said, no, we don't normally check where our garlic's coming from. About 10% said that they do check, okay? And they 10% of them, so that's about, I would say about 1.5% said they knew that it came from China. And people sometimes, about 5% checked sometimes, and out of that 15% knew it came from China. So most people did not check where their garlic was coming from. This is the processed garlic, and quite a lot of them, some of them knew and some of them didn't, that it came from China. Then we asked them, where do you think processed garlic come from? So never mind what you buy, but where do you think it comes from? And this was the results we got. About 40% said they came from France, 38% China, and so on and so forth, and decreasing. So about, I would say, roughly 40% of the people surveyed knew that China was a producer and we were getting imported garlic from China. So then we asked them, what kind of label would you like to see on these processed garlic? Okay, so we gave them various options, where it's grown, where it's packaged, processing origin, growth to the journey it took, farming practices, processing practices, and then authenticity, it is actually garlic. And we found nearly 90% of the people preferred, that was their preferred first option, is that, authentication, that whatever they were buying was garlic. And there was around 40 to 35% people who wanted to know about the traceability information. So there is authenticity seems to be the most important quality that they wanted on their label, and then about the traceability information. So in terms of trust, how do we measure trust? We are on a scale of 1 to 7. We ask people, low trust is 1, high trust is 7. How much do you trust farmers, manufacturers? And you could ask this question of any kind of actors along the food chains that you're interested in. And we asked before we showed them the authenticated, traceable garlic, and then after. And what I'm going to show you is the difference between what they said before and after that information. And we found that there were significant increases in everything after they saw the traceable authenticated information. So this is for Germany, is blue, green is this is Germany here, and this is UK here, and blue is before, and which is the baseline, and green is after. And as you can see, in both Germany and in the UK, trust enhanced in the farmers, trust enhanced after they saw the authenticated traceable information. Similar patterns were obtained. This is for manufacturers who make garlic. Okay, in both countries, there were significant increases. And this was on the product, the garlic itself. Okay, so what we found that in the trust by using authentication, using QR code is just a method, but giving authentication information and traceable information to the consumers about the product does increase their trust in the product and the actors along the chain who are producing it. In addition, we asked them, what do you think about this garlic? This garlic that has had authenticated and traceable information supplied to you, what do you perceive about those garlic? Well, they perceive those garlic to be more accurately labeled, which is true, more expensive. You would expect it to be, I suppose, assume that it might be more expensive because more work has gone into it. But they also perceived it to be safer, of better quality, and healthier because it had been authenticated and because it has been traced. Overall, participants' intention to buy increased. Okay, so they said they would buy this because 1 is no, we don't want to buy it. 7 is yes. So it was around 5. So it's higher than the average. There was intention to buy. And when we asked them how much extra are you willing to pay for these things, about roughly, let's say 20%, a fifth of them said no, we're not willing to pay anymore. But about a fifth said yes, we'll pay about 10% more. And there was an increase up to about, I would say, extra 20%. So there is a market for these kind of product where people trust the product to be better, quality, safer, healthier. They are willing to pay more, and they also trust the processors, the farmers, and the product because they have seen this information and it has been communicated to them in some means. So, in conclusion, the provision of traceability and authenticity information leads to greater trust in the product and the actors in the food chain. Consumers intend to purchase traceable and authenticated processed Chinese garlic over non-traceable one that is on the market. consumers have more positive perceptions towards the traceable one over the non-traceable one, if you like, because they consider it to be healthier, safer, tastier, etc. Consumers are willing to pay extra, minimum 10%. Not everyone, but there is a market for it. So our conclusion is provision of traceability and authenticity verification is a promising strategy to improve EU consumers' trust in the Chinese products, very similar to what we found when consumers were asked about their EU-produced products. Thank you very much. I would like to thank my collaborators on this work, Dr. Tony Benson and Dr. Michelle Spence and Professor Elliott. Thank you very much.
Thank you very much, Moira, for an excellent presentation about the garlic case study. And it is extremely interesting. It's not so much about where your food comes from. It's about guaranteeing that it is genuine, it is authentic. And I guess the case study for garlic you could use in many, many other types of foodstuffs, do you think?
Yes, Chris, I agree, because this mirrors what we have found with your local produce produced in the UK or in EU. So, when we did the beef study, when we did the oregano study, it's very, very similar in terms of people want to know that the product that they are getting is authentic. And they also want to know that every step has been monitored. And then if they want to, that they can trace it. It's not, there is, when we ask people, they did not always want to use the QR code to find out whether, where it came from or what the journey it has taken. But the fact that it was given and it is checkable, if you like, for them, is the guarantee that it is like an insurance certificate. That you are willing as a manufacturer, as a processor, to share this information with us, gives us the trust, gives us the guarantee that you are open and transparent. And I think that is what is important. It doesn't matter where actually the product is made, because we can't all be producing all the food products that we want to eat in one country. So
perfect. And I know this was very much about European consumers' perceptions, but you've also done a lot of work in China also. And is there a similar finding there? It's just, please tell us that the food is genuine, it's safe to eat, and other issues about country of origin and so forth are less important, or is there a different dynamic in China?
Well, I think as part of the project, we did two products. We did one, we did both ways. So a product that comes from China to EU, and we chose garlic. And because, it was one of we could have chosen tomatoes and so on, but, garlic was a case study that we chose. In terms of produce going from the EU to China, we did baby milk because of the scandal and so on, and so on. And there is still a little bit lingering uncertainty. I know China is working very hard to counter that, and and making sure that there's a lot of traceable, authenticated Chinese produce, production of milk that is going there. But there is, from when we looked at it, we didn't look at that aspect. We were only looking at enhancing trade. So when we go from EU to China, they want to make sure that it is what it is, but the mechanism of communication, they want to check more processes. So they want to make sure that the packaging hasn't been opened, so we need to have enhanced technological solutions. Just a simple QR code is not enough. So we have looked at different technological solutions that could guarantee the product that they are getting is what they paid for, coming from where they wanted it to come from. But in other produce, I am sure it would be of a similar kind of things which we could investigate.
So Moira, many thanks again. Great presentation.
Thank you, Chris.
So that completes all of our presentations for our EU-China Safe Day at CIFSQ. I want to thank all of our speakers, both from the morning session and the afternoon session, for giving such high quality knowledge information to the audience. And I hope that we have been able to convince all of the people who have either attended in person, who are logged in, the importance of the work that we've been doing for the past 4 years. And what we want to do is to try to ensure the sustainability of lots of the different connections and collaborations that we have developed over this time period. We still have another 4 months of the project to run, and we will be having some final dissemination events. And I very much hope that at the CIFSQ conference next year in Shanghai, that we will be presenting some of the final outputs of our project. So what I would like to do now is formally thank all of the speakers and thank all of the audience as well for a very, very good session. I'm absolutely delighted with how it's gone. I would also like to take this opportunity to thank Professor Wu for his friendship, for his cooperation, collaboration over the last 4 years. It's been a wonderful partnership. So perhaps now, Yongning, if you're still in the audience, I should pass back to you just to close the session formally, if that's okay.
Okay, thank you. And just thanks, Chris, and thank all the speakers online. And we will be close our session. Bye, Chris. Then maybe close. Bye. Thank you. Okay.
Bye, everybody.
Yeah, bye.
Bye, thank you.